There's supposed to be a delay in there. Why was there no delay? Hold on, let's get YouTube comments up before I forget. Twitch. No. Twitch.tv/YouTube. No. YouTube, Adobother VOD. There it is. Here's my stream with my beautiful thumbnail. Pause. And pop out the chat. Do I want YouTube TV? No, I don't. Who would have thought? Okay, so I got all my stuff together. This thing is playing. Fast forward where I can hear music. There it is. Okay, this is Blumencraft. It's a very old OTT album. What are we doing? Let's see here. That on-air light should have had more of a delay. It came on instantly. So why is that happening? The China mode. Yeah, that's a Wexo. Another Wexo sending in. So stream starts. That's like, that's on the other page. This is a complicated flow for my stream starts soon light. It needs to incorporate YouTube in it. That's this metadata line that I was testing out. It doesn't really work. But what does work is this top part of the flow. So state changed. Delete the topic of the thing. Check out to see whether or not it contains start or stopped. And if it contains start or stopped, we turn red, green, whatever color. Why didn't it delay 7 seconds before it turned red? That should have delayed a full 7 seconds. Yeah, the code actually is spaghetti. It is literally a plate of spaghetti. 7 seconds it should be delaying. Maybe we'll put the delay over here after the filter. Yeah, maybe we'll do that. That goes there. But then before we get to the light bulb, pull this in a little bit. So that's going to give a full 7 seconds before anything happens. Green is a delay of 10 minutes to turn it off so that the light isn't constantly on when I'm not on the air. But if I open up OBS, it'll turn purple. And actually, maybe purple should also get a delay in case I open OBS, but then I never go online. Purple should probably go in here. Just so that in 10 minutes, if I keep OBS open, the purple light will stop being annoying. Yeah, that's probably good. I should probably do that. For days when I work on... Well, it doesn't really need to turn off if it's gone purple. That's fine. If I've got OBS open and... I can always inject off on my own, and it's not that... No, we should do it. I should do it still. Rules is rules. All right, deploy that. I don't think that thing's going to get any signals from reboot. Oh, there it goes, yeah. There he goes. So there's the full... There's that 7-second delay that allows me to switch cameras, and then you can see stuff happening. Cool. Yeah, that's pretty cool. Yeah, so from my thumbnail, this tree stand safety is what we're doing today. I need to build this one of these little feet for this tree stand, and we'll print it in gray, and then I'll switch over to black and get that printed in black. But this is a hashtag AutoCAD ad, so naturally the first thing to do before stream technically starts is to boot up Fusion360, because Fusion360 is always a hassle when I'm streaming. It's going to eat up all my memory, and it's going to want to restart, or it's going to want to restart itself, and I'll restart it, of course. But we'll get that all updated before we actually get to work. It is a monster pain to have to do this every time, but hey, you know, hey, with updates come new features, I guess, is something. So apparently Nucleaires has had a ton of updates, and Tomato did 2 streams with it that I was sort of bumming around with, and it looks a lot of fun. It looks like it's a lot of fun because you can actually turn on chemicals, and then you can have xenon poisoning, in your reactor, which is when xenon bubbles stop your moderator from stopping the fusion reaction, or not fusion, the fissile reaction or whatever of the fissible material, right? And so it gets hotter and hotter and hotter. It's what happened to Chernobyl, I believe. Wasn't that one? That one was xenon poisoning, wasn't it? Their dark mode looks pretty good. Save 30% on additional fusions. No, I'm good, man. Listen, I'm already pimping out my own fusion thing here. Look at the dark mode. I haven't used fusion a lot in the past couple days. We've been doing stuff with high voltage. Let's update now, and it's just going to be a little choppy. Oh, yeah, and on the high voltage circuit, I came up with the solution. The solution. This blew up. This blowed up. So here's what we need to do. Instead of the 2N5551 just hanging out in space, we need to have a current limiting resistor of something like 200, 100 ohms. I think. One to 200 ohms, and then this is a bypass. And so we will have actually under that another transistor that will cut off this stuff. So actually, let me redraw this. Let's just grab this and move it away. So here's the beautiful solution to all of my problems. And it's actually quite clever, and it's something I read in a forum. I read it in a forum. And then I guess we can get rid of this branch. And then I'll take this, bring it over here. It may look like a ladder, but it's not. It's worse. And then we'll drop this down a little bit. Why did that change selection type? Weird. Give me another one of those. Actually, move the other one up. Go up a little bit. You delete. You delete. Delete all of the lines that are not necessary. All right, that one and that one and that one and that one. And then I'll take this one and bring it back over like this and just put it right in the way. Perfect. Great. And another one and another one. Delete this message, and then, okay, so 2 transistors. And although, you know, we could control this just with electrical engineering, right? I could find the point that this thing switches and make it switch when a certain voltage is achieved, which would make it totally passive. We already have a microcontroller in there, and it'll be funny if I get it wrong. So what's going to happen is around 200 ohms. I was doing all this calculation on my walk with my dog, and so I'm not sure if this is the right value. We could make it a lot less, but this is just designed to kickstart it. So this is a bypass. So what happens is, through the current limiting resistor, we allow it to start charging the capacitors. So 100 volts, 200 ohms, V is equal to IR. And then what is it? Watts is equal to V times I, right? What's the watts again? Yeah, it's a soft start. That's apparently the prevailing solution here. I think I got that right? P is equal to VI. Which is A. That's weird. Dot product of V and I. So if we do V equals IR, 200 ohms, 100 volts over 200, 1/2 of a watt. So if this is 400 ohms, I can use a quarter watt or an 0805. So that should probably be 400 ohms. And I don't know what I forget what the capacitor equation is. But we've got something like 200 WV. What? 15 times 3, so 4,500. Oops. Repeat. 4,500. Right? 1,500. Yeah, 4,500 UF. So how much energy are we getting in there by doing a quarter watt? Wow. 400. Although if that's 1/4 of an amp, that's still overloading our poor little guy over here. 80 milliamps is all this thing can do. 80 out of 100. It's an eighth. So we're kind of like doubling the amount of current this thing likes to provide. So we might need 800. How long does 80 milliamps take to charge the capacitor bank? It is 4,500 microfarads. So we can do capacitor calculator, capacitance conversion calculator. Oh, this is probably just turns it and other stuff. Pico, nano, micro, whatever. So, well, under farad, 4,500. What does that equal to? 0.0045. We'll remember that for later. Capacitor time equation. Don't you AI me. Don't you AI me. I don't know enough to comment on the AI. Study.com. What is this? What is this? Resistor to capacitor connected series show below. How long after closing the switch would it take? 6.05 turning into amps. Oh, you're giving RC ln VO over V. 1/5 of its original voltage. Wait, we don't have V in here? Oh. Oh, you're calculating for 1/5. Come on. V is equal to VO, E negative 1 over RC. I don't know, man. QD is equal to E minus T, little t over big T. Ah, get out of here. Supply voltage, 100. Capacitance of microfarad, 4500. Series resistance, this is 800 ohms. Calc. 3 seconds. So it'd take 3 seconds through this. Three seconds with an 80 milliamp current limiting resistor, which brings that power supply up to its maximum. But I wonder well, the bypass, the cutoff needs to be there. Does the bypass even need to be there? If we give it an 800 ohm resistor, did I put in 800 or did I put in 4? Oops. Moving to feature hubs. I need to do that at some point. Restart Fusion. Too many things going on at once. I get this music going and I just become a work machine. 800 I put in. So that's 3 seconds. So somebody puts the emote in, 3, 2, 1, boom. And that thing charges up and it goes, well, 4 seconds. Realistically, how long is 4 seconds? Oh, wait, hold on. We can do this better than that. Boop. Delay 4 seconds, and then we'll just hit it into the ideal light. So 4 seconds, is that going to be, it'll be emote in chat, and then this goes off. Wait, that didn't do anything. Whoa, okay, oh wow. That's emote in chat. That is unacceptable. That is unacceptable. Actually, I should have punched this into the system over here. Wait a minute. If the emote, oh, no, get out of here. Delay 4 seconds if there is an emote. So if you put the "ah" into chat, the ideal light comes on. But the delay on it is 4 seconds. So did I deploy that? I'm gonna hit deploy again. Deploy. So now it's like here's the delay. That's completely unacceptable. That is unacceptable. The thing would charge up in like a half a second before. It would totally hurt the power supply, but the power supply can take it because it only has to do this intermittently. So, oh, I'm going to get the notes into the code. Hold on. Through 800 ohm limiting resistor, 80 mA, charges in 4 seconds. Does that work out? Does the math on that if it's 1/8 of a watt going through? I think it does. The math is funny because it's all, but I want it 80 milliamps. But that means in 1 second we are 1/4 of the way through, and so if for less than a second, so like something like 500 milliseconds, we start charging up. Oops, that's my thumbnail. We hit it for like 500 milliseconds, and then we hit the bypass, which the bypass can take up to, I think it was like 600 milliamps or something. Hopefully we don't burn out one of our transistors, because that's what happened last time, is we let it go just raw dog straight into the capacitors, and it was enough to blow it up. So this is not what we're working on today. This is the start soon portion of the stream. So we have not started the stream yet. Although somebody will inevitably ask me about that. But yeah, when we're charging this up, I mean, this is going to be taking all the amps that the power supply can give. And it seems like one of the final stages of this thing is a big cap inside of this power supply. So what happens is that big cap discharges through the transistor and it explodes. So what I want to have happen is for 800 milliseconds, our path is going to go through this 800 ohm resistor, and so we'll only get theoretically 800 milliamps. What's that calculation? It's 100 over 800 is equal to 1/8. So 1/8 of 1. That's not right. That's 0.125. That's not 800 mil. That's not 80 milliamps. That's 0.125. That's 125 milliamps, which I think the power supply might be able to take. That's 125. Oops, sorry. I love this album. This is a really good album. This is Blumencraft from OTT. I love OTT. 100 volts through an 800 ohm resistor, 4,500 microfarads, 22.5 joules, 3.6 seconds until it's charged. This is all using the capacitor equation as if I was familiar with it, which is why I love these calculators, because you can just find a little Java calculator for most of what you're looking for. Nowadays, though, you're going to have to maybe rely on AI in order to do stuff like that, because all the Java calculators are going to be taken down because nobody can afford the hosting anymore, and everything just goes to shit, apparently. But I like my little world of these sort of clunky Java calculators instead of trusting my own ability to do math. I could open up a textbook, but it would take me too long to get familiar with the equations again. And so I think DigiKey's taken up some of those calculators, and they have them on their website, which is pretty cool. Although it's a commerce site, that's like nice of them to do. It puts you on DigiKey's website, and maybe you'll buy something while you're there. But having just these little dumpy little calculators is great. I'd rather not use Excel or some Google product to figure out what the hell's going on. So, oh God, let's get rid of the Rizin Kizma Riza medical thing. I'm just closing stuff that I don't need because Chrome is just loves your memory, and it has all your memory in its mouth. And I would like to get a little bit out of there. This is what? Raspberry Pi RP2040. Close that. I do need to get back to the design of the keyboard stuff. I got kind of burned on that because when I built the part in Fusion, and I had to violate some rules in order to make castellated edges. And when I pulled that part into my design and updated it with the slightly rule violating stuff, it went and replaced the parts of my part with other parts. And it should never do that. It should never do that. The part is the part. And you can warn me about the part, but the part should be like uneditable, I guess. I mean, maybe there's an instance where you would want that to happen, but yeah, 95, 55, 35. We are going to be calling upon 125 milliamps for it. So it's going to be doing absolute balls out maximum when it starts to charge through the resistor, but it won't be doing above that. That's the point, is that it's not going to be completely hammered away or hammered by it. What's up, Cyber Whiskey? Oh, did I? Why didn't that up? Wait, what's going on? After soft start, everything just decided to stop working over here. Oh, probably because the memory of, yeah, let's just do that, and then that might refresh it. How's it going? What's up, lines and squares? I didn't see your chat message because Chrome was shutting down tabs in order to conserve memory. This, I don't know. It's possible that I could use a new computer, and it would be smart for me to get one, but I don't have the money. I don't have the money. I did my taxes. Pennsylvania took hundreds of dollars from me because my investments did too good. My investments did good, and suddenly taxman cometh and taketh away my Pennsylvania rebates for being a poor person. Well, yeah, so 4 seconds is completely unacceptable from a delay. So charging for 4 seconds is just out of the question. So we have to, with the soft start circuit, I have the ability to bypass the current limiting resistor, the current limiting resistor is what keeps it to a 4-second charge time. So the 3.8, but it's we'll just put 4 down there. So in something like half a second, we'll let it soft start and then bypass it with the transistor. Wow, how much current are we going to be putting through our poor little transistors? They might blow up again. So whenever we get back to this, probably on Thursday, we'll build this circuit and blow it up and see what happens. And when that blows up, we'll start it by soft starting from the start. Like we won't activate the bypass at all, and we'll let it charge, and we'll see if it blows up the transistor, which it won't. And then I'll activate the bypass on one, and it'll explode. But today we're busting out the calipers. I'm going to build a part in Fusion360. We're just going to do a little bit of reverse engineering of a tree stand safety, of a Christmas tree stand, and we'll build that in one day, and then I can get this thing out of the shop. Get out of my shop, you Christmas tree stand. Nucleaires is just such a great game because it's like a, here, go, make the power plant do power plant stuff without ruining the entire coast of whatever country we're in. It just doesn't hold your hand for anything. It kind of explains stuff that you might need to do, but you have to have understanding of how a nuclear power plant works. And if you don't know, nuclear power plant, you basically have this fissible material that's letting out all of these like neutrons and stuff like that, right? It's real dangerous, a lot of radiation coming off of it. When you surround it with certain rods, it will absorb that stuff that it's throwing out, and so it doesn't heat up as much. When you remove those rods, it'll heat up a whole bunch. And so mankind, in its infinite pursuit of new energies, because every time, every age of mankind is revolved around an energy type, right? We are currently in a time of electrical energy and lithium-ion batteries and stuff like that, right? I mean, they are steering society in a direction, right? It's kind of crazy how this works. So new energy source, awesome. We got nuclear material. Of course, they tried to make nuclear material work for anything they could possibly throw at it. They were putting it in the oil of tractors, putting it in tractor oil so that the farmer could scan the engine with a radiation detector to see if it's leaking oil. Like, they were looking for a problem everywhere that this stuff could solve. It turns out it doesn't solve too many problems. But also in the infinite age of mankind, throughout the eons of our existence, we have decided that all technology should revolve around boiling water. We are really good at boiling water. As engineers, as a society, we are really good at boiling water. Everything we do, aside from some of the more modern things that are going on, is designed to turn a thing. And we mostly do that by boiling water. We take a magnet and we spin it inside of an electric field. And when you do that, it induces current, right? So everything boils down to spinning. And most of the big energy that we get out of stuff is with boiling water. So we're like, hey, that rock gets a little hot. Let's condense that. Oh, wow, now we've made this really, really dangerous material that can just boil water. And so we use the boiled water to boil water. And then that spins a turbine. And then you have to recondense the water again. And so you've got these big towers that people call smokestacks when they're dumb. But really what they are is convection air that's moving up through a solid solid thing. So we spray the water and then air comes down and up through it. And even then, sometimes that's more different water. Like, there's different waters in a reactor. And sometimes you even have liquid mercury that's taking the heat out of the radiation stuff. But in nuclears, it's all water. So you have this extremely high pressure steam, water, that goes through the reactor core, gets really, really hot, gets a lot of energy in it, because water is very difficult to sort of move the energy around. That's why we use it for water cooling and stuff, because when you've got all that energy, what you can do is you can spread the water out, cool it, put it into something like a computer chip that's hot, and all of that energy is going to get absorbed by the water, which doesn't like to change temperature. It's really cool stuff. So the water inside the reactor is superheated, which means it's kind of still water for the time being, but it passes by the reactor in an extremely dense form, and it picks up all that heat and turns into really, really high pressure steam. And so that really, really high pressure steam is put through a heat exchanger where it turns other water into steam. And then that other water is not like radioactive, it doesn't need to be special water, but that special, the less special water then goes through a whole bunch of turbine blades while it's expanding, and it gives all of this energy, and down, like, we're so efficient with turbines that the turbine is down to actually absorbing heat in order to run better. Weird. It's weird stuff. We're really good at extracting energy from steam. Like, really shocking. It's kind of weird. So we spin this big turbine, and then we put it into a coil of wire in a changing magnetic field. It just changes its position by spinning a lot, and that creates a buttload of energy. And so that energy is in an AC wave, and the energy in the grid is an AC wave. And if two AC waves that are out of phase 90 degrees run into each other, they cancel out. So you need to very carefully control the frequency and the phase of that AC that you're generating before you connect it to the grid. So that's what that game is about. That's all that stuff. You got to use a synchrometer in order to balance the AC wave and get it right and not suck power out of the grid. But it's really cool. Geothermal energy, yeah, this is a great one because we've actually learned how to take boiling water and put it into a turbine. Well, okay, so like, you know, coal, clean coal. We've learned to take the coal and burn it in order to make steam and put that through a turbine. Yeah, but I mean, listen, you know, you can have what is it called? Hydro, what the fuck? Hydropower, I'll just say. And that doesn't involve steam. That involves putting water through a turbine and spinning a thing. All we do is spin stuff. There was actually a really cool, what was it, Real Engineering, with this like new super crazy fusion energy kind of thing. And what it was is basically they used, I think it was deuterium, but they made these two plasma rings and they compressed them with a magnetic field until they were these two little tiny plasma rings that crash into each other, and then it releases a whole buttload of energy in the presence of a magnetic field and a coil. And so they put that energy into a buttload of capacitors. They just had a warehouse filled with shelves and all these different capacitors, and apparently that can create a lot of energy, just crashing the plasma together like you're one of those monkeys with cymbals, little wind-up guys. Boom, 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 and you got a bunch of capacitors and you have energy. So that was the only time that I've seen something go directly to electricity. And then eventually, I think that reaction might make some deuterium. I'm not sure. The big boy fusion reactions are supposed to be able to make the helium-3 that would be required to have fusion. So we're getting there. We're getting close to a totally novel and not boil water. Actually, wait, are they just... Is that what they're doing with fusion? They're making plasma and shaping plasma inside of a magnetic field in order to create an incredible amount of energy that is really, really hot and boils water. And then the water goes into a turbine. It's like the square hole meme. Everything we do boils water. But we're really good. We're really good at making... Ow. Oh, I found a knot in my beard. We're really good at making steam into spinning. And we're really good at making spinning into electricity. So it's like to a hammer. Everything looks like a nail. Yeah, direct electricity, solar panels, and then there's some kind of a like trench technology where if you have your nuclear gas go into like a silicon material, supposedly whatever that's giving off can knock electrons around and get them to move. Similar to solar, I think. I think that's how those nuclear batteries are working. The nuclear batteries certainly do not contain steam. I hope. But photovoltaics is basically you have a high energy light particle, I suppose, and it gets into the silicon and it slaps it around a little bit, and that gets electrons to flow. It kind of smacks it around. But yeah, this is all in relation to nucleaires, my commentary on power generation. Nucleaires, brilliant game. It puts you in the control room. You can do all kinds of stuff. Replace a foot. What happened? Is it because of the diabetics? No, it's not. We're not replacing my foot. My diabetes is under control. Look, here, you can see it. You can see it right now. My diabetes is completely under control. Ah, fuck. I had noodles for lunch. Noodles are like pure carbohydrate, and so this happens. But it's on it. You can see it's plateaued already. It's kind of gonna be on its way down. That or it'll just stay there all afternoon. I really hope it doesn't do that. I hope my shit is aggressive enough to bring it back down. That's not the foot we're replacing. No, the foot we're replacing has to do with tree stand safety. We'll have to do another nuclear stream, by the way, because I mean, not because Tomato played it. I'm not just copying the games other streamers play. Maybe I am not above that. Ugh. But I want to play because there's achievements now. None of the achievements from when we played and I generated electricity for like 45 seconds. It was like a minute. It was like 2 minutes. We generated electricity, and then in order to avoid legal consequences of me being the only person running a nuclear reactor, because everybody else called in sick that day, I fled on the train, basically fleeing the lawyers. It's not really so much the fallout that I'm worried about. It's the legal consequences and the congressional hearings and all that stuff that I'm going to have to go through if we mess up running the nuclear reactor, because everybody called in sick that day. Everyone called in sick. Everyone called in sick. Aggressive blood sugar consuming cardio shit. That's part and parcel of why I take my dog for walks after meals now. Take my dog for a walk after meals, and sometimes that'll kind of rattle loose whatever the liver is fucking doing, because the liver can really fuck with your glucose levels. Like, as soon as you drink orange juice, your glucose level starts to go up. That's because the liver is like, oh my god, carbs, here, glycogen, glycine, whatever, just start, here's some sugar to start you off, so you have energy to chew, I guess. Thank you for streaming despite your blood sugar doing whatever it wants. This is not whatever it wants. This is exactly expected of what was going to happen to it after eating a bowl of noodles. I love in the comments, like I was reading, like, well, your first mistake is that you were reading Reddit. But when I read like the ramen noodles Reddit, and people are like, I have 2 packages in a sitting, and I'm like, holy shit, dude. Like, this is what 1 packet does to me. It's all the plan. It's kind of junk food. I mean, come on, it's junk food. I need to eat a little healthier. But I did take Willow on a walk after eating, so I think that's helping a little bit with the absorption and stuff. But yeah, it's mostly the liver messing with you, and then you get to deal with the consequences. And bolusing very early, I haven't gotten a good hang of. You can give your insulin ahead of time, and that will, eventually you give insulin like an hour to a half hour ahead of time, and so the insulin will peak, your glucose level will fall, and you catch it by eating something. And I got to get better at doing that. Would it look the same after eating a bowl of corn or rice? It depends on how complicated the carbohydrates are. I believe noodles are relatively complicated, but they're not super complicated. Milk is from what I understand, a complicated carbohydrate, and its onset is after much time, which is funny because I've read stories before of people like giving milk to diabetics. People are like, oh, milk, that's a good idea, that's full of carbohydrates. And they're like, blah, blah, blah. It's actually kind of a long-acting carb. Because it's so complicated, your body has to break it down. There's still the liver immediately giving you stuff, but yeah. But again, like healthier foods, grainy breads, all that kind of stuff takes a little bit longer for your body to break down. So those are just a little bit better, just a little bit better. I love this album. When did this come out? It was probably like 2004. It doesn't say. This was posted 9 years ago on a channel that's not OTT's channel. Anyway, Blue Man Craft is a very good album. Good psychedelic, trancey kind of stuff. That's the right there. Humans are not made to manage PID systems. It's a little bit more than that. It's actually the PID system that I control in order to do this is dictated by your body's instant ability. Stop doing systems control. It's not natural. No, this thing right here, the control system is very annoying. The control system sucks because your body over millions and billions of years, or however fuck long, has basically mastered extracting glucose from stuff. So you eat the stuff, your liver for some reason gives you a ton of energy that it's then going to reabsorb, and then eventually your stomach will break the stuff down into stuff that you need, right? So it does that very quickly. But because this insulin is not my own, I'm gonna burp. Because the insulin is not my own natural insulin, and because I'm injecting it intramuscularly, that's a safety thing, it gets absorbed and peaks around 15 minutes to an hour, and it stays in the body for up to 4 hours. So it is insulin is a long process on a very short process. So it's hard to get that control system exactly right. And that's where my phone comes into play. That's why I have Android Auto Pancreas system, and that can very quickly, not very quickly, sorry, that can not visualize because it's a computer program, that can act on my glucose levels in that time scale without distraction and without, you know, it's its whole purpose and it does it automatically, right? So that's so much better than the human meat brain trying to come up with some kind of an unnatural control system that works outside of our own ability to pay attention to things. Somebody in Tomatoes chat was like, "Oh my God, Bother, I love your content." And I was like, "Oh crap, I had to be quiet then because that would piss off the streamer to no end." It was a good stream. I liked it. You guys go watch the VOD. That's been bugging me for like 3 days. We've been working on this stuff for way too long. Wait, why is it? Oh, did we never? I never saved it. Mix panel, fart noise, solenoid skeleton. Yeah, solenoid skeleton. Kicker schematic. Yeah, so wait, did this one didn't? It still says soft start. Hold on a second. Sounds like circus music. You bite your tongue. Let's restart this thing. What do I do for that? Display? No, that's chat. Just chat back. Overlay audio. Bowser. What doing? Not have nuclear bomb. Nope. Let's get rid of that one. I forget how. Okay, never mind. Where is that? Okay, there it is. Properties. Refresh. There we go. Okay, so that'll come back. Check to see if there's any YouTube chatters. No YouTube chatters. All right, let's see. What else do we have here? I've got Twitch open. I've got Streamlabs open. 7 days was the last activity from anything. That's fine. Yeah, I think I'm good. We'll just gonna finish out the pre-stream area. It sucks that I had to wipe the cache of my chat. Now it's gonna be blank for so long. But yeah, so we went into Node-RED and we tried working with the delay that's going to be on the emote kicker. 4 seconds is too much. So what I've decided to, I mean, we need to have this with 0 resistance here and this big capacitor hopefully discharge. There's a big cap here that will discharge. Actually, let's find out how quick that capacitor will discharge while we're sitting here doing nothing else. Better than being idle. It's weird, I don't see any. Oh yeah, that cap definitely, because that big line right there swings up and goes to the positive lead. So let's just, for the sake of argument, say 10 microfarads. That's a Nishan. Nishan. I hear good things. 10 microfarads at 100 volts. Let's do the online capacitor calculator. 100 volts, 10. I don't know what the series resistance is going to be. Let's make it 1 ohm. Okay, so that's going to discharge in 0.0000100 seconds. How many coulombs? Coulombs. OMBS. God damn it. Yeah, all right. So 10 microfarads. Was that 10 or did I get that wrong? No, it's 10 UF. Very small amount of energy. Huh, would have expected a larger one. But this was enough to kill our transistors. So in 0.0000100 seconds. So I mean, this could be a very rapidly activated bypass. I could wait like 1 microsecond. I could potentially wait 1 microsecond and then hand it over to the power supply where it won't put out more than 80 milliamps. Because that would be whatever I, through series of 1 ohm resistor, I did a charge rate, but the discharge would be even faster. I don't know. Maybe I could have calculated the discharge a little better. But the discharge into these would be, yeah, okay, all right. I think that works out, I'm not sure. All right, so this is going to be a new project. And hopefully this takes 1 stream. I'm going to assume that it takes 1 stream. We'll probably have to put the camera, the burn the subs camera, on, like point it at the 3D printer, which is over there, which has not been started up in a week. So the 3D printer is like right over my left shoulder there. It's just right there, right back there. All these popular like makers, they're like my new Bamboo Labs printer, and I'm like, ha 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 ha, that's neat. I emailed them. I emailed Bamboo Labs, and they did not reply to me. So I'm not cool enough or popular enough to get a Bamboo Labs printer, which is sad. Sad state of affairs. I don't think I'd have room for it over there, but it would be nice to get a plug-and-play printer. My brother, my brother got one, and he's like, yeah, you just turn it on and it works. I'm like, I don't like you anymore. Get out of my face. My calipers are over here. Hold on, I gotta get my calipers. Definitely need calipers. I have been somewhat messing with Bazite OS on the Legion Go, and it's pretty snappy. I'm actually quite happy with it. I've done a couple sessions of remote gaming. I have to see if it works on my friend's network, and I need to finish being able to virtual desktop into it. I need to do that. That's signing up for, like, what is it called? I forget the name. It's some virtual desktop, like you got a VPN tunnel into the actual machine, and then it's just like a little virtual gaming desktop. Do you have a CNC? I do not. I have a milling machine, and that's just right over here. And we haven't had any projects for the milling machine lately. This is technically a Sieg X3. It's kind of more a drill press. It's a drill press with bearings that can, and a spindle that can take side forces. So I use the Tormach quick change system, which I actually really love. Even though this is manually operated, it's got knobs that I spin, and it's got a DRO that gives me the coordinates. The x-axis on this thing has broken, and so what we need to do at some point, when I totally burn out on electrical stuff, we need to take this apart down to its bones, and I need to improve it. I've seen machinists on YouTube fill the base with a bunch of material and then epoxy it. I'm not going to do weird stuff like that. I would like to get a counterweight for the spindle, and I would like to change the spindle over to a 3-phase motor. I have a 3-phase motor that I can put on that thing, and then if we use belts, it'll be a much quieter system. This will be able to run faster and more accurately. Not that that's a super thing that I need, it's just that I have the extra motor from the steering wheel project. That's a project that'll take you a year to finish. No. Machining stuff takes way less time. We can take that thing apart, and I can, look, you know, I work on cars, or at least I used to. I know what I'm doing. I don't think that'll take a year. Over there's the steering wheel project. You can barely see it here. There it is. Steering wheel project. This is a steering wheel made out of real car parts. And then I have pedals that are also real car parts. But this, we actually need to 3D scan this so I can make the airbag for it. And I want to get back and do some gaming streams with this thing. But anyway, this thing has the motor that I would use, the 1/2 horsepower or 1/4 horsepower. I don't know. This motor here is comparable to the most brutal of the direct drive steering wheel systems that are out there, the stuff from Granite Devices and others. But yeah, one of those motors would go into the milling machine here. It's a big, wide, small motor. So that would probably go on top, and I've seen it done before. I've seen that project before. Goes on top, and then I need to get like a certain type of V-belt pulley to put up there. I have all the plans here. Let me see if I can find it. See if I can find what the plans that I found. Hey, Mahalo. Is burn the subs working? You know the answer to that, Hedonica. I don't know why you would ask that. Go over here and go to, actually we need to go to my directory here. So we go to project, I think mill move. I don't think that's the right one. Oh, those are just pictures of when my buddy and I were moving the mill in. Oh my God, it's a goofy looking bother. Jeez, I used to look like that. Actually, I still kind of do. All right, we don't close shave the beard anymore. All right, get me out of there. So let's see. There's another milling machine. Oh, that's the data sheet. These are the manuals. What happened to that mod thing? This isn't the right thing. No, this is all the wrong data. I had a PDF with plans in it. Oh, that's the DRO. Ah. Huh. So I thought there was more in there. Oh, is there a mill mods? Mill to servo. There we go. That's what I'm looking at. That's the instruction manual for the Mitsubishi inverter. I don't really need this. I don't know why I held on to this. Yeah, here we go. So, Sieg X3. A mad scientist in the natural element. No comment. Bought in 2005. This is a little better than mine. And I don't need the power feed. We might eventually CNC it, but yeah. So counterweight with just two. Those pulleys are way too big. I think I can put a piece of 80/20 rail on the top of the mill and then put a pulley on either side, a smaller pulley. £100 of old Transformers stampings. I actually might have something similar to that. Delrin bushing in the base table. So yeah, I might have literally can unwind a couple transformers that I have. And then here's what they did for the belt. Instead of a toothed belt, they go with a V drive, I think. Oh no, maybe this guy did use that. The one that I saw used a multiple V belt. It has multiple V's in it in order to give you that friction. But this is just some random PDF that I found. Yeah, they didn't quite do what I would do. What I saw done. What I saw them do. What I saw that day changed me. Belt tracking adjustment, ordered from stock drive products. Yeah, this isn't, oh, it's weird. So, Sieg X3 belt mod. Yeah, this is the one. Save as. Oh, wait, I'm not going to be able to save into the directory. Damn it. All right, to the desktop. And I think I made a temporary stream project here. New folder. Mill mods. Just save that so that I have it in case this goes down. My current mill has a small tooth belt. That's why it makes all that rattling noise when it August 2009. Oh boy. So that's what originally is there. That's the motor off to the side. Goes in a big tooth belt over to this tooth belt, which I think is spinning. Well, it goes down to the gearbox and then it comes back up and spins this, which is this is the drawbar thingamajig. To something like that. Wait a minute, that doesn't look right. This isn't the one that I was looking for. Oh man, they did a bunch of calculations. I don't want to do that. Oh, and they have a lathe. Oh, I see. They have multiple speeds that they can put into there. Huh. This is not what I'm looking at doing. This is a very similar motor, though. I think it's just about the same mounts. And they put it off to the side, huh? The one I saw had the motor on top of the thing instead of off to the side, which is kind of what I'd want to do. That's a tensioner. Look at all that. Jeez. This is the part where it would take a year. CNC zone. Come on, I'm human. Look at me. I'm aging. Dude. No pictures. No pictures. Okay, get out of here. Yeah, the one I saw had a thick thing on it. What is? Wait. Belt drive conversion kit. No more broken drive gears. Much quieter operation. Spindle speed up to 4,300 RPM. Ideal for manual and CNC mills. Check compatibility. I can just buy a kit. Although these plates look like something that I could build. So I couldn't build these though. But yeah, that'd be something to look at. Mini mill. X2 SS. That's not X3 though. My stupid stuff? What stupid stuff did you do? Not quite seeing it. CNC, you get it? Here's your drive. Okay, what is that? What the fuck? Let's see. Show me the motor. That's a good one. That's a good upgrade. I did that. I have a microscope light that sits around that. I did the same thing. I didn't do that. I don't know what the hell's going on here. Okay, not what I'm looking for. Tax CNC upgrades? Oh, this might be the death of... Oh, no, okay. So that's fine. Those work, but oh my God. Ugh. Okay, so it was one of these. I just don't... Oh, wait. Oh, maybe it's from the YouTube video. Yeah, see, something like this. Where they're putting a big V belt in there instead of the timing belt. Oh, we got a sub. Siflet8 saying, sup, mother. How's it going? I'm just looking at mill mods while we mill around here before we start stream. Yeah, maybe it was one of these YouTube videos that I looked at, actually. And that's why I don't have a file saved. That's essentially what we're going to be reducing it to, is a big pile of parts on the workbench. It is a 350-pound milling machine, so it'll be nice to reduce it a little bit so I can work on it. Because we've needed, we've needed the mill to work, and the DRO is broken, so we got to get to the bottom of that one too. But I would like to have a quieter motor on the whole thing and have it be a little bit more spry, and that could lead later on to CNC-izing it. Although it is nice to move the spindles yourself and get a feel for how it's cutting. Because, you know, listen, you guys, if you watch YouTube, have you heard of this website? It's called YouTube. If you've watched this website called YouTube and you've looked at some of the machinists' videos on there, boy, those guys define running things fast and hard. They kick those machines into the absolute. Yeah, it's a relatively new website. Came around. I think it exists because of a nipple slip or something. But anyway, so all these YouTube machinists, to get that exciting shot, I guess, they run their machines at the ragged edge. They're like, how fast can I run this? And while in industry, that's fine. That's what you're supposed to do. Time is money, right? Time is money. In industry, they're like, do it. I don't care if it's a $20 end mill that you blew up. That's $20 versus the hundreds that I'm paying you per hour. So, like, whatever, just go do it. That's fine, but if you're home machining something, or you're maybe a little bit remote and ordering stuff isn't that easy, or you don't have spares of something, or you're just slow it down a little bit, please. For fuck's sake. These YouTube machinists, I love watching them. I love their content, but they're like, all right, let's see how this does. And it's like, like, stop it. They're throwing away hours of work by running everything at the ragged edge of what the settings should be. You can slow it down a little bit. The mic cable wrapped around the stool and then unplugged itself. Yeah, I'm not talking about a specific CNC channel, but I mean, you can insert your favorite CNC machine into what I'm talking about, and they probably apply, because all of these guys, they go in, all these people, they go in and they look at the book, and the book says this is how fast you should run through this material with this deep of a cut. They go, cool, let me do that. Back it off of that a little bit. Come back to reality a little bit more. We're not, you know, if you get that shot, you could just speed it up in your video editing software, right? You just speed it up. You're a YouTuber, for Christ's sake. You can edit your video. If you were streaming it, then fine. Yeah, go to the ragged edge. Blow it up. That's great. Because, you know, streamers, time is money. It would be better to finish something quickly. But again, like if you're doing a YouTube video, just like be kinder to your equipment. But I guess the channels that I watch are popular enough that they're just going to buy new stuff. I guess that's just the way it works. You're here taking care of a tool like it's a part of your family. You're not just blowing it up. It is about, oh my God, I had a lot to catch up on. We've been doing a lot this week. Willow is a little bit sick. My puppy dog, she's sick. She's got, her nose is a little bit warm. They're like drag racers. If you don't break something, you left some performance on the table. That's not, if you're building a thing that takes multiple operation and takes hours to get to the point you've got it to, why are you still running on the ragged edge? I don't understand. It's not like a drag racer. You're not trying to get through and get the part done at record speed. It's crazy. It's crazy. It's unhinged behavior. Anyway, yeah, my puppy's a little sick today. She's not feeling herself. She's been hanging out around the shop more than usual, because usually she sits at the front door. I'm yelling at the furniture right now, so she obviously doesn't want to spend any time around me because I'm loud and obnoxious. But she's been, you know, crawling under the desk at night, so I think she's got a little cold or something like that. Little something going on. Hopefully she'll be okay. Who can mill the aluminum block the fastest? That's something for like Tormach to do, not for like a YouTuber to do. All right, let's get the music out of here. Bonk. Okay. Nobody's tested my Node Red Flow yet. That's fine. That's fine. Hi, welcome to my channel. If you've never seen it before, this is basically a shop where I pretty much just exist. It's all I do. I'm just here. But I stream stuff. I stream these projects that I work on, and you know, sometimes we have pretty good content. Apparently, people tell me. It takes a while to build stuff. I like to actually like build things instead of just sort of like doing like crappy work or doing things too quickly and breaking stuff, as we're talking about in the chat, or just not like getting stuff done. Well, I don't get a lot of stuff done, let's be honest. I need to finish projects, and we've got a lot of projects going on currently. One of the things that I didn't really tell you guys about was that, you know, this is a Christmas tree stand, so obviously you can tell how long I've not been working on this, but this is a plastic Christmas tree stand. It's slightly more environmental, I think, than getting a pine tree every year. I'm not sure. It has little rubber feet on the end, but it only has 3, and there's 4 legs, 3 little rubbly bits. One of them fell out. So naturally, using Fusion360 and a 3D printer, we can make another one. You see, I'm using Fusion360. It's a program that I kind of cut my teeth on. In college, we used AutoCAD, so I kind of knew the scheme of laying out a 2-dimensional drawing and then popping it out in 3D. And I don't think we got to the point where we added chamfers to everything, but it was sort of in one of those intro courses to like CAD design way back in the early 2000s when I was in college. I'm an old man on Twitch. Let's just get that out of the way. So yeah, I know AutoCAD, and so when it got to 3D printing, when I finally sort of caved and decided to have a 3D printer, I believe I tried FreeCAD. It didn't click immediately. I downloaded Rhino because it's what my mechanical engineering friend uses. I didn't really like its interface. I didn't try it very much. And then I got AutoCAD and AutoCAD Inventor, and I pooped around with that for a little bit, and I did some stuff. And then when it came to like building solids for 3D printing, I decided to try Fusion 360, in part because it was AutoCAD and I understood how the workflow worked. And then the other part of it was that Fusion AutoCAD, Autodesk, absorbed Eagle. Eagle was the consumery kind of DIYer's way to build a circuit board. Eagle CAD was this way to put parts down with, you put parts together with a schematic and then you ran traces. And it was fairly rudimentary, but it had a lot of like user language programs and stuff you could use. There was a lot of like flexibility in what you were doing, and it was a one-time fee to get the program. So I learned it and I knew it very well. And I said, what happened? And then somebody told me, hey, it's free, but it's part of Fusion 360 now. And I said, that sucks. That's terrible. I hate this. And then I got to using it, and it turns out that for the sort of soup the nuts, the napkin to fruition engineering that we do on this channel, like where if I have like something that I need a 3D enclosure on, Fusion 360 is actually pretty good. You can use websites or various other sources to get 3D models of stuff, and then you can build solids around it that you're going to 3D print. And if you plan things out right, you can work from the 3D print bed up and create pretty complicated looking things and interesting looking things that'll hold your stuff together. Or you can be like one of my viewers and you can print out 500,000 of my emotes after I send you a vector graphic. For some reason, I mean, nobody asked. I didn't ask. I don't know why I have all these freaking emotes in my, just everywhere. It's like, I think there's one in my underpants right now. It's ridiculous. But yeah, anyway, Fusion enables you to make those solids. Now, there's plenty of programs that do the same thing. This is just the workflow that I know, and I actually really kind of like the program. In posting YouTube videos, Autodesk, or at least the community manager for the Autodesk relations for like YouTubers mostly, in uploading my VODs to this channel, if you're watching on YouTube, if not, it's at obothervod, o_bother. They found me and they said, wait, this guy does electronics? Let's see if we can swindle him into using our program, which wasn't necessary because I was already using it. They just basically said, hey, if you want a copy of this program, do a couple sponsored ads. And all you have to do is put hashtag AutoCAD ad on it. We're not going to tell you to speak positively about anything. Just make sure that you get all the logo and the branding right. I'm like, that's a perfect relationship right there. Like that, I don't have to do anything that's out of my way. I already use this program, so that's why I'm using Fusion 360, right? And it's been pretty good to me. It's actually been a pretty good sort of matchup of capabilities here. Now, we haven't really ventured into the paid stuff for this. We mostly stay towards the functionality of the free version, right? And so what we're able to do in here is design electronics, get a 3D picture of the circuit board, a 3D model of the circuit board that's complicated enough that, first of all, it looks really good. Second of all, it informs us of where all the stuff in the circuit board will be, and I can make stuff around it. We've done a whole computer project doing that in the past. Today, we are not doing anything that's nearly that complicated. We are doing the sort of home gamer typical use of a 3D printer, and that is indeed to create one foot that will replace the missing foot on a Christmas tree stand. So I thought that would have been a good one stream project. Now, it's not trivial, but it is easy. All we need to do is sort of hump the calipers for a little while and see if we can recreate this sort of thing. So how does this whole thing work? Well, looks like the leg is just this very, I mean, look, everything that's produced nowadays is made to the utmost maximum of mankind's ability to technologically cheapen everything, right? This is a punched piece of sheet metal. Fusion has sheet metal capabilities. We're not using the Fusion sheet metal capabilities. It kind of scares me. I think I'd be able to learn it, but anyway, this is just a painted piece of sheet metal that's been stamped, right? It's probably one of those things where it like stamps it and then everything moves to the right and then it stamps it again. But basically what's holding in that foot is just this little tab of metal. So that's nice. There's already a quote-unquote fastener for us to use. Foot itself. Let's take a look at the design of the foot itself, and we'll see what we can replicate on this thing. Wish animals could talk so we could take care of them better when they're sick. I don't want my cat to tell me how they feel at times. They try to bite my fingers off. Willow will tell me how she feels by throwing up on the carpet, which I don't think she's done. I don't think she's that kind of sick. I think she's just a little ick right now. She's just been kind of keeping close. So if we're going to 3D print this and it's not going to immediately explode, we're not going to keep the thin side walls. Now this is not a rubbery plastic, right? This isn't rubbly at all. I can't deform this in any way. So we're actually pretty good to use PETG here. It'll pretty much be exactly like the foot that we already have. And after all, it's all about the feet that we made along the way. There's a little bit of overlap so that it covers over the sheet metal. That means we're probably going to have to print it either on this axis, so it's going to look a little weird. When you 3D print a part like this, whatever's touching the bed will take on the texture of the bed. So if I wanted to, I could put down like painter's tape or something and get a texture similar to this, or I could just leave it the way it is, and then it would look like the F around and find out sign, like this. Have just this weird marquee style dot pattern on it. And what that is I print with PETG, and I print hot, and I print fast, so things look a little gross, right? Things look a little gross, but yeah, the layers are a bit bad sometimes. So yeah, the marquee pattern is because of the material that I use. I don't use any kind of an adhesive like Elmer's glue would be a good release mechanism actually for PETG, but with a glass bed, PETG is too sticky, and it can pull up glass fibers after only a couple prints because it sticks so good. So Creality has a specific, I think it's probably Teflon, but they put the Teflon in sort of the reverse pattern to what you're seeing here, and so the smooth parts are created by the bare glass. That's what's holding your print on. Everything else is a no-stick material, and it's close enough together that when it's printing, it's not going to cause any issues with the filament, with the plastic being put down. So I think it's a perfect printing surface. I don't need to use any kind of all I do is, so my maintenance between prints, every now and then, like every 5 prints, I'll go through, spritz it with Windex and just wipe it off. That's it. That's all I do. There's no extra anything to that. So that's what we're going to print it in, and all we need to do is just design a similar part that I suppose is going to be filled with plastic. So what we'll do is I can do a couple slot cutouts on the sides, just slot cutouts on the sides, keep the entire inside of this thing solid. It's PETG, so you could run over it with your car and it wouldn't deform. But then we need to figure out some angles that all this stuff is going to be at, and we'll see if we can get it to fit nicely. I don't think I'm going to need a model of the leg. I don't think I'm going to need that. So we'll go directly from this thing. What I'm looking for is what axis am I going to put on the print bed? If I want to get a little texture out of the foot, I don't think I want this to be the one facing down. Although this being the layer that's on the bottom would probably turn out the best, because it would then support these little overhangs and stuff. We're definitely not doing this little tiny lip on the bottom. I actually think, I wonder if that's pressed in instead of molded in. I wonder if they actually press that pattern in, because this has a little bit of an overlap on the bottom. There's a little bit of it sticking out. That's a weird thing for them to do. Why wouldn't they just mold it in? Weird. That might be pressed in waffle pattern. Waffle stomped into the part, if you will. And you will. Oh yes, you will. Yeah, all right. if we take this as the bottom surface, that'll print okay. If it's solid inside of there, and then we can get all the other dimensions correct. So we'll probably be, I don't know if we'll be cutting that out from a side view. If we extrude that all the way up and then I cut from there. Well, first things first, let's just get started. We'll start with a square. Start with a big old square for that. So, AutoCAD, the whole methodology behind this thing, and what somebody said to me once is that if you're doing something in CAD, you basically want to start with like the type of manufacturing that you're using. So if I'm doing a lathe, I want to do like circular. I don't know if that's still true, but like if you're doing milling, you start with a square piece of metal and you kind of like put all the stuff into it and think about your tool paths as you do that. With 3D printing, you start from the ground plane and you work your way up. So that's kind of what I'm doing. It's kind of what I'm considering when I do it. With AutoCAD, you start with sketches and then you extrude those sketches. So we need to begin with a sketch. So over here, this is a new file. It's untitled. I'm going to hit Control S, make sure I'm in the right directory. I need to switch to the modern directory things. I haven't done that yet. This would be admin project. I guess we'll put that in stream projects. Well, that's gonna mess me up when it comes time to print a new one because one of the other legs have fallen off. Stream projects, we'll just put it in the base directory of stream projects, and I'll close that because all I need to do is hit Control S, and then I'm gonna call this Xmas foot. So the Christmas tree stand foot. But bother, nothing happened. I know, we're still in version 0. So now we select the plane where we want the sketch to actually be. That's going to be the lines that will dictate the shape of our overall part. But our part has all these weird features to it. What can we include in this initial sketch? Well, it seems like mostly all of the other faces are going to be working off of this sort of outer square that sort of dictates the size of this whole thing. When measuring this, I am going to measure from the outer areas. Now, does it taper in? It does appear to taper in on the very bottom, but I don't know if we'll stress that yet because it's a very minor taper. Let's take it at its maximum and then figure out whether or not we want it to sort of have the sort of angled sides, the trapezoidal sides. Because I can always add, I can do a front sketch and then I can add just a little angle to it by extruding outwards. So actually, that is a pretty prominent feature. This isn't it. That's all right. Let's just get to measuring. I don't have any great advice when using calipers. I use Mitutoyo calipers, and so they are pretty good. They're pretty good at returning and repeatability. See that? The repeatability is pretty good at that. And you just have to watch that you're not putting too much pressure in there. And when you're getting the dimensions of something like this, you kind of press in a little bit and then make sure it's just a little tiny bit loose to give you your measurement. So 18.17 millimeters. I'm not sure if I should shave off that 0.17 and just do this at 18 millimeters. I assume that this thing was designed somewhere overseas, and so it's really probably not using English measurements. I think I'm going with, because we got an 18 there for just a second. Now it really seems like it's 18.2. The 0.2 plus and minus comes from the 3D print's ability to grip a screw. If you want the screw to fall through the hole, you go up 0.2 millimeter. If you want the 3D print to grip the screw hard, you go down 0.2 millimeter from the measurement. If you want the screw to go in and just not have all that much grip, you go right at the measurement. That's sort of the, and that'll vary depending on your 3D printer. You'll have to measure versus your own 3D printer. You can obviously just print like a little tiny plate with holes in it and test that against your screws. But for me, it's plus minus 0.2 is really the sort of friction fit versus really tight, almost breaks the screw head off fit versus the screw falls through. And sometimes I'll bump that up even more just by a little bit in order to make it all that much more easy to, you know, like assemble stuff. So anyway, we're going to start with a sketch on the base plane here, and we're just going to use that as our analog to the 3D printer axis. So it's going to take you into a two-dimensional view. You can always hit Control and move the view around when you're in this view and snap it back using the view cube up top. But basically, just have fun, sketch something, right? And we'll use construction lines in order to dictate some of the other stuff that's going on here. So we've got 18 for the width. What about the length at the... this whole thing is a trapezoid, isn't it? This has like a taper angle to it. Talk about over-designed. Jeez. Bring this in to show you guys. Look at this. So... trapezoid. It's a zoid, a trapezoid. Remember zoids? I remember zoids. This is just a weird shape. It's all just weird. It's like here. That's load-bearing rust. That's load-bearing rust. Twisted Sister's going to come in and be like, what the fuck did you do to my... Everything about this is weird. Why can't you just be normal? Okay, there's our square angle. What'd you do to your nail? Which one? This one? I think I was stripping wires with it. It's not having a good time. It'll come back. It always does. So that is our straight angle. That's going to be a weird one. Well, the side profile is going to do all the cutting. That's going to be where things get weird. We'll have to, maybe I'll have to grab angle blocks to measure these. Oh, wait, I have an angle measuring tool, don't I? Yeah, look at that, just that little weird thing there. Okay, so that's our start. That's our square. We're going to first extrude a square, so I need to find out what this height here is, because that's going to be my maximum height, and then we'll cut everything else out of the block. So we're actually measuring to there. 18 millimeters. Another 18, so 18 is the extrusion. 18 is the width, and then the length is going to be from the base to the back, and that's 26. 26, 18, 18. It's always fun to like learn how they engineered it while you're reverse engineering it. So that one is 18, and the top one is 26. Another cool thing about AutoCAD, and I'm sure other CAD programs do this, you can, like, the sky's the limit when it comes to these measurements. If I did 26 and then I had like +4, -12, that's still going to figure out what the dimension is, and when you double click it, it'll present you with your entire equation. Pretty cool. And if I happen to have like 4 inches in there, it'll still do the equation as long as you give it units after what you've done. So 28 millimeters minus 4 inches plus 12 millimeters. Pretty cool. You can also put variables into there, but apparently people don't like it when you do that. Sometimes people make things generative, or not generative, but they're whatever. They're based on measurements that you can go in and edit in order to create, like in order to alter the sketch. Now, when you're doing something in AutoCAD, something really important to think about is the timeline. The timeline is one of the more powerful features in this program, and it dictates how everything goes together. The timeline is this bar at the bottom here. And the bar at the bottom is each individual step that you've gone through in order to make this part. So if you make the part and you want to go in and alter something, you can go double click into the step and it'll reverse the timeline to that step, and you can alter things within that step. Now, that can cause havoc later on. You may have to go in and edit all the preceding steps in order to make sure that your part goes together properly. You can still do that. And one thing to watch out for is when the different elements of your sketch start overlapping with one another. So if I do something that's measurement driven and I change the measurement and that moves this circle in, what that'll do is that'll create new enclosed areas of your drawing. And these enclosed areas are used by AutoCAD in order to do the subsequent extrusion steps and things like that. So the program will make an assumption for what you want of these new areas. and that can really mess up your drawings later on down the line. We've gone into some pretty genuinely complicated drawings and had to go in and fix by redefining the areas that things extrude and all that stuff. It's just something to watch out for when you're building your initial part as you go through the program. But it is all solvable. It doesn't necessarily permanently break everything. Things get pretty complicated though, so you want to be a little wary of that. So okay, we've made a square. Congratulations, streamer! You've outdone yourself. You finally made a square in a two-dimensional drawing program. Finish the sketch, and now we've just got square sketch visible on the plane. Wow. Okay, so E for extrude, or you can go up to the tools and select extrude. I'm still getting used to what this stuff looks like in dark mode. So we are extruding. We are extruding this square, and we're going to go 18 millimeters upwards. 1/8 millimeter. Boom. All right, so there's our initial solid. Now the initial solid assumes that you have like a mild steel. You can change the default material if you like. Typically when I'm done the part, I will visually make it look right by turning it into like a matte gray or something like that. If you're rendering it, you can assign materials and then it'll render into something that looks very, very much like the actual material. I never render. I don't do renderings. I'm not presenting clients with these whoa, look at this rendering of this thing. I've not ever been presented with that. So I don't do renderings. I will make this look good in this view. So in this sort of outlined engineering looking view. It's a very pretty program, and I use it because it's pretty. Now that square sketch we don't need anymore, so I can unview that sketch. We can get a better impression of what our square looks like. It appears to be made out of square. Perfect. What I'm going to need to do is come up with a side profile, and I think that side profile is going to basically inform every other part of the part. You can change the color of objects while working in CAD Drawing 2 under the Rendering tab. It's useful if you have two parts drawings. Interesting. Yeah, there's the render. There's a whole animation engine that I haven't played with. Yeah, render right there. The A key is one of my favorite things. It's the appearance key, and that's where you can look through all of your different materials and decide what your thing is going to look like. Oh, where did they go? There we go. Yeah, in the different tabs. This is a little clunky. Night mode is still a little clunky. They didn't. Some of the menus aren't quite agreeing. That's all right though. So anyway, we've got a box. We need to turn this box into this. So currently, we need a couple angles here. Guardian angle. Giardian angle. No, wait, that's Beaver Fever. You know what I'm going to do? I'm going to get angle blocks, and that way we can get some precise numbers associated with the different cuts that we're going to have to make out of our solid. So I'm going to get my angle blocks. You guys look at that thing for a minute. Angly blocks. Those are the gauge blocks. Those are not what I'm looking for. I'm looking for the thing under it, which is the Big Anytime Tools angle block collection. These are good to have, these angle blocks, in lieu of having a protractor or some other type of angle measurement device. We're not, this isn't like, there we go. Yeah, I just have a couple of these little angle bros. These are rusting. All my tools are going to shit. These were not expensive though. These are because they're not good. Good ones are expensive. We don't have good ones here. Oh, I've got a larger. Don't I have a larger one of these? Didn't I buy? Yeah, that's what that one is. Let's go get a larger, whatever it is. I forget what that's called. I don't remember. I don't remember machinist stuff. There's a hole in my brain. Yeah, I got my faithful, not really quality tools. These are just random Amazon things that I buy. They do well enough for what we do. Speed square? Is that what that's called? I don't listen. I only watch YouTube machinists. I don't know anything about anything. I've never taken a class. I don't like how these have the branding on it. Gauge square. I don't know. No, that's not right. It's gauge block. But maybe just squares. I think they might just be called squares. The problem with having the ideal light is that the ideal light needs to be in every shot. And so I'm fairly limited with the shots that I can construct. So this one is a right angle, pretty well proven right there. There's no, what I'm looking for is to see if I can see any light between this thing and the angle. And what I'm seeing is plenty of light, but that's because it seems like they pressed that waffle pattern out of the bottom, and that created a lip around the whole thing, which makes it a little harder for us to get accurate measurements of stuff. What I can see is that it's a consistent gap between the two going upwards. So that is definitely a right angle. Over here, what I'm going to do is use the gauge blocks to figure out what this angle over here is. So right now we can see not really that well that it does actually get wider as the thing goes up. And so I will measure the angle. Does it change? Wait a minute. There may be two angles here. What does it look like over here? I can, oh yes, okay. Yeah, it's two angles. We're going to turn it into one angle just because for complexity, but look at that. Wait, where is it? There it is. See that light gap? It gets wider. But that's like less than a millimeter. That's ridiculous. Yeah, I'm just going for an overall angle. You should buy a digital angle meter. I mean, I've got one of the little beepy ones that does gravity. This is something that's not going to make it into my design because we're not looking to completely reverse engineer this. It seems like what they did is they added just a tiny little angle flare at the bottom of this thing. So why it like widens the foot just a little bit. I don't think I'm going to worry about that though. We're just going to go for like an overall angle. So what angle is that thing at? A very, very small one indeed. I think it might be 2 degrees. Try 2. Oh, it needs to be, I need to lift it up just a little bit. I don't know. I'm rooting for that one. The camera's out of focus, but you guys can see that little light gap. Gotta make sure it's not the reflection. Yeah, I gotta focus closer. Okay, you guys need to be able to see. Arm focus. Go! Oh, my head. You hit my head and now I've got fuzzy vision. Yeah. Okay. Look at this. I really don't like that they say faithful on them. Sort of not good. I want to say it's 2 degrees because this is, I mean, this is parallel. I think it's a 2 degree taper. And it would be different if I actually dealt with that little bubble, but we are touching at the top and the bottom, so I think that is 2 degrees. Let us go with that. All right, now I've got all this crap on the desk that I got to move this, close this. We need to get many more angles than this, so we're not done yet. Now, what I'm doing now is actually designing this as if I'm machining it out of one piece. So I guess all the stuff that I said earlier about considering how it's going to 3D print is just out the window. I'm just looking at different machine operations at this point. It seems like we're making it out of a block of steel. So whatever. Everything I say is a lie. Nothing I say is true. Let us put a sketch on the side, and then we can extrude through in order to cut out those shapes. So we are going to create a sketch, and that's on the side. And it's a separate sketch. It's sometimes in drawings when it gets really, really complicated and there's a lot of stuff going on, I'll start naming things. So instead of sketch 1 and 2, I could call this front and side and all that stuff. But in this case, I don't think it's going to get that complicated. So I'm going to start with a line where I haven't really defined anything. I'm just going to go up here and attach it up to this. And it looks like they've got some kind of a new thing that's adding sketch lines. See how that there's like a dotted line up top going to the center. Weird. Yes, that's the whole point. It is famous last words. Oh, so 89 degrees. Really? Is that going to be 89 degrees? Maybe I should do a top and a bottom measurement. No, but there's going to be another angle coming off of this. So this adds a sketch line, and what that sketch line is doing is it's defining the 90-degree point from which I am measuring this angle. So it's kind of going to get sloppy. There's going to be a lot of like measurements on the board here. A lot of weird dotted lines and solid lines. The thing is, the solid lines that you enclose become a feature. So we've got our solid line going up, and it's contacting this top line. So we're creating an enclosed area here. And from that enclosed area, if I hit Finish Sketch, the sketch is still visible on the side. I hit Extrude, highlight that area, and then just drag it through my solid, and that'll make our angled cut. So now this is slightly and annoyingly trapezoidal, much like the part that we're looking at. Now here's one thing that I actually want to do is I'm going to take that dimension and I'm going to measure it at the top and at the bottom. So if I measure from here to here, I think this is slightly lower out here. Wait, let's check. Yeah, maybe that's not a good measurement, because this is a right angle. But then this is not a right angle. I could get out all the geometry stuff to try to measure it. Oh wait, that is a right angle. Wait a sec, those are at the same height? Oh, but wait, the taper's going into the... yeah, those are a right angle. Okay, so these two tops are at the same height. We'll just double check that. Father's talking about his tops again. 17.7. That's really 17.6. This is kind of 17.6. Okay, all right. Playing Schedule 1, I noticed the person who's on the money in that game looks kind of like the main character's uncle. It probably is. That game's pretty funny. Boy howdy, that person became a multimillionaire overnight, didn't they? Whoever made Schedule 1, that's crazy. So 17.6. We made it 18. Maybe we need to modify that just so our numbers are okay. So what I can do, go back to this extrusion and make this 17.6. There we go. And now we're 17.6 high. So I can actually measure the top and the bottom. So the bottom obviously is 18 because we've already measured that. But if I measure the top, then I can redefine how that line comes in. So at the top, I kind of want to get it just barely to hold on. 24.9, so 25. This one's 25. All right, so we're talking about very, very small distances here that are beyond my ability. They're not beyond my ability to measure, but they're beyond my ability to care. This surpasses the ability for the streamer to care about measuring it accurately. 25.7. So it's really 25.8. And then this is sort of all the way on the edge there. 25.23. So 25.75 and 25.25. We could try that, I guess. Sketch 1 is this dimension. 25.75. Finish. And then if I go into the side sketch, you can see it reverses time and my extrusion is now grayed out. And instead of doing this on an angle, I'm going to delete that, which is going to cause havoc. Hey, my Aegis, how you doing? Got a new phone. Who's this? I don't know anymore. So I hit X to make it a construction line, and then we take that from back here where we're measuring, and we take it out 25.25. This is ridiculous. The little tiny elements of design in this foot for a Christmas tree are way too much. I should not care about that this much. So anyway, I'll take it up to there. There. Instead of measuring it by angle, and actually, what angle is that at? Let's measure this and this. 88.4. I had it at 89. Wait. I had it at 88. So we're 0.4 degrees off. Whatever. That's the 3D. When the slicer gets to this, the slicer is going to be like, what are you doing? So now that extrusion might break. Nope, it actually inferred the right thing. Okay, so now we have our frustratingly small angle cut. I don't know, what would you do with a foot? I don't have a foot. If I had a foot, we wouldn't be doing this. No, this is it's a Christmas tree stand for a Christmas tree, and one of the feet went missing. So I'm going to print something that sort of looks like the right thing. Kind of the same thing I did with a washing machine, where I printed the little pin that holds the wheel onto the axle. And the PETG has survived the washing machine. I've had one of them break since I fixed it like a year ago. Okay, so that's one little weird, frustrating angle. The next one, we need to figure out where that goes. There was some construction going on up the street, and I heard somebody yell out in kind of extreme pain. I don't know what the heck was going on, but I guess we can keep doing this with distances, although that might be a little bit frustrating. This is going all the way up to the back corner, so we can start in the back corner. We're going, for the washing machine, is ASA not a better idea? What? No, it's a dishwasher, not washing machine. And regardless of whether or not it's a better idea, what I did works, and I used PETG. So there are just a bunch of angles that we're going to have to just kind of figure out, I suppose. So I guess instead of doing like an XY of where this corner is, although that might be a good way to do it. Yeah, let's do the XY of where this corner is, and we'll do a square from the right. So 5.5, and then 7.4. So let's see if that does it right. So back to sketch 2, and then I'll take this and I'll make a construction box, and that's going to go 5.5 and 7.4. 5574. That's going to create that bottom piece. Let's see. And that goes up to this, which is 2 point. I'm going to call that 3. I'm going to call that 3, but I might regret it. PETG is just what I have on hand. Why is that dotted line there? What did that? Oh, that's the construction line for this. I hope that doesn't mean that whatever I do here. Okay, so. Oh, but that goes out from here. Yeah, so this is just going to be a line, and it'll be 3. Like that. Away. It's kind of hard to see when the solid is here. I could unview the body, and then we can see the sketch a little better. Although in night mode makes the sketch lines sort of hard to make out, huh? They're working on it. Yeah, I've got an open frame printer, and I can't just work with any material that anybody can cook up. I have PETG. That's sort of the gist of it. So yeah, line just directly down from there to this. That's one of our lines. Now we need to do the one that goes... Oh, am I going the wrong way? Yeah, we're on the wrong... Whoopsie-daisy! I'm turned around. I'm going to Control-Z my way out of this. I'm working up here. This is 3 millimeters. So 3 this way. And then I measured from, ooh, that's a tapered piece, so I don't actually know the measurement there. So I need to go from all the way over here to the corner, which is a hard measurement to do. Let's have something to put up against it. So here. What happened? Okay. Getting these measurements is not easy. Let's see. So I can put this up like this. No, not quite. Here we go, like this. Wait, but that tapers upwards. So I actually can't, I guess I could go like this. This is close enough. Near enough makes no difference. 18 1/4 and then 5 up. So this is from the right angle end. So this is going to be a big box, I guess. I don't know. I'm just making this up as I go. So is it 5 or is it 5 point something or other? Oh, it's actually closer to 6. We'll make that 6. Oops, that should have been construction. So double click on the thing to do the whole surround and then hit X. There you go. There's a construction line. So one of these comes from 3 millimeters down to there. And then the other one, what's the height of that thing? Oh, that's on the right angle too. So that's actually perfect. 7.5. 7.6. Yeah, I get 5, 6 every time. So 7.6. So another construction line coming up from our right angle that doesn't have the cut in it. And that's going to be 7.6. Probably cleaner to do if I did this with measuring angles, but those blocks were kind of annoying to figure out, especially because the base is flared just a little bit. You should always use a flared base, but I mean, that's another stuff, not in 3D printing. But yeah, so, okay, the next one is going to be, I guess I could do the height across this line, and that'll give me that part there. So use that and maybe get into the corner. I'm running out of hands to hold this thing while I do the measurements. Two and a half. Are we willing to accept 2.5? I think I am. So I guess if you were doing this legitimately, you would probably find a datum that you would take all your measurements from. I'm not doing that. I'm going just with whatever. 2.5, which means that if I adjust something, everything is going to be adjusted. So this is essentially a slow car crash that you guys are watching, where presumably eventually all this is going to come crashing down and I will have no idea how to fix it. But we're starting to get all of our structures together. The last thing to do is to get this like chunk out of it. Now, is the chunk done at an angle, just like everything else? I guess it does match, kinda. How am I gonna do that one? That's an interesting one because it's angled based on this piece here. So it is going to be what? I guess I can go distance from the corner. Like that. So that's 6.5. 6.6. Everything is 0.6 of this thing. Everything is 0.6. What's going on? Maybe I'm not measuring it on the right. Okay, that one is 6. Double check with this. Yeah. So we're going like 6.2, 6.4. And it can be wider than that too. So 6.4. But if, okay, so this is 6.3, I guess. And then 6.3 and then go 3 in from that. So 6.6 would be to the center. Is that, wait, no, that's 9.6. Yeah, 9.6 to the center. And then 3 from the top. How am I going to do that? Yeah, see, that'll go along there, but I need, so here, 9.6, not 5, just 9.6 to the center. That doesn't quite look right. And then this one coming down here, yep, at a right angle to that. And then that's what, how's the depth of my, how deep are you? 3. So 3 plus 1.5, so 4.5. And our box's center is right there. How am I going to angle that properly? Well, create, I could do a slot or I could just do a square. I guess what it has is a square, so we'll do create a square from the center. That, and then that will be, what was it? It was 3 by 6. Yeah, 3 tall, and then 6 point. I'm gonna give it 6.2 because the thing is like 6.14. If I give it 6.2, the foot might wobble a little bit, but we can fix that later. So right now we are not anchoring this. Well, that one is anchoring it horizontally. So I want to get rid of this anchor. So we're going to go up here to constraints and go to, wait, did the body come back in? The body should not be visible. What happened there? The highlighting is annoying enough in dark mode. Now where's remove constraint? Symmetry, curvature, polygon. I think maybe I have to select the individual constraint. Oh my God, please stop. Profile, there we go. Oh, that feels better. Oh, right click, right? Is that right? Curvature? Yeah, I think I've used it before, but I can't remember where. I don't know what that would constrain. There's all kinds of weird stuff. These constraints are really important. So when you're making a sketch, your sketch is a bunch of lines, right? And when you build a shape, the shape defines that each of these lines is parallel to the others, right? Since it was a center square, I get the X in the middle too. But those constraints are what's going to keep your drawings honest. If I try to drag this anywhere, it's not going to move, right? But if I get rid of the constraint here on it being horizontal, I can then drag one of these and it'll start moving around. I don't know what you're talking about, Copper. What are you talking about? So I need to remove that constraint, and I'm just looking for where I do that. I forget where I do that. Do I right click on it? Or do I control click? No, shift click. No. Constraints, dimensions. What if I get rid of points, dimensions, geometries, construction? Oh, I need that. Now just click on the, nope, that doesn't do it. That highlights the whole line. Bring this back in. Oh, and schedule one, okay. Come on, I used to know how to do this. Fillet, chamfer, trim, sketch scale, change parameters, constraints, nothing. Configure, inspect. All right, I'm gonna Google it. I'm gonna Google it. A lot of these questions are on Fusion360 forums and stuff, so sometimes it's pretty easy to just open up a thing. Have there been no YouTube chatters, or have they been another window? There have been no YouTube chatters today. Are we streaming on? Yeah, because I couldn't have gotten it. I'm just going to check. Oh, bother VOD, that comes up, and then there's that, and then I'm live, and yeah, we just haven't had anybody talk in chat. Okay, cool. Someone will come along eventually. Okay, so I am Googling. I'm just going to do Fusion360 remove constraint. Easy way to remove constraints. They're going to tell me to use the command line. I lurk, therefore I am. Oh, well, mahalo. Coming into YouTube chat for nothing. You delete a sketch constraint by selecting correspondent constraint glyph. Thanks. The small white icon on the canvas indicating the coincident point, etc., and then pressing the delete key. I have tried this, and for some reason it's not letting me. Oh, okay. It was highlighting, but because we're in night mode, I didn't see it. I didn't see it. Okay, so now what I'm going to do is constrain these to be parallel. So this one and this one are parallel. And because that one is locked down, this one will follow it. And actually, we're just going to make this, and this into the hole. Bada bing. Where did this go? What? Wait, did I? Huh? Snap, sketch grid, dimensions, points, profile. Oh, I see. So that was, we didn't redraw that. That was defined by the other sketches profile from the extrusion. I see. So this is every feature that we need in order to create this solid. And we'll have to figure out what some depths are too. So let's finish the sketch. And now we have nothing. Oh my God. Let's bring in the body. Huh? Where's the body? What the? Oh, because of the sketch settings. Snap, slice, profile, points, dimension. No, wait, that's in. I have that in. Finish the sketch. Everything's gone. What the? Oh, so it extruded the whole thing instead of what I wanted it to do. What happened to? Wait, but the cut is in the not. I guess it just selected everything else because I made a bunch of new dimensions. Weird. Okay, so now that that cut is made, we can also use that cut here to make our top cut. Yes, yes. And now we need to figure out what the rest of the dimensions are. So come back in here, and then we've got 4 minus 3.18. Are you kidding me? A lot of the dimensions are wrong because this flares out of the base, but we'll just see how close we get it. So yeah, this is 1.6. Am I going to count that as 2, or do I do 1.6 so it fits a little bit more tightly? Yeah, we do 1.6. I could do a fancy extrude on this and have it go symmetrically. I mean, let's try. Hit E for extrude. Select this. And our distance is going to be... That goes symmetric from that point, but I think I can do... Can I do an offset on that? No. Yeah, so we're just going to go one side on that and do 1.6 millimeter. But it's actually not adding material, we're subtracting it, so we've just put a minus on it. Boink, and that's going to make that cut. Okay. And then extrude this, and we're going to go in, I don't know how far. I mean, I guess I could just do it to like, I could go through the whole thing. That's going to make a big tunnel. I don't think I want a big tunnel through the whole thing. It's going to have some support material, I think. I don't think it'll be able to build itself. Let's just go negative. Well, okay, I'll measure it. I'll measure the damn thing. Oh, it looks like this is blown out anyway. This is bent. Okay. Oh, okay. Calipers, hello. 2.3, so let's make that 3 millimeters. 3 millimeters, give it a little room. All right, now I got to do the same thing from the other side. So extrude, select that plane, but then we are going to do from object. So start object here, and we're going to go, what was it? 1.6. And that's a cut because it goes into the other solid. And then I'm going to extrude this guy, start object over here, and that's 3. Oh, wait, 4.6. That makes our in-cut 3. So we're going to go back and edit this one. Now, if I can't find it, I can just click on this, and it's actually going to, oh no, I can click on the 3D, not the sketch. So if I unview the sketch and I click on this, the step where I make that feature is going to not highlight. It should highlight. It should highlight that. Oh, maybe in night mode it's broken. Usually when you click on something like that, it'll actually show you. What kind of caliper is this? This is a Mitutoyo caliper. Mitutoyo. I forget what the, it's like 100 and, no, what is it? It's 210 millimeters. Mitutoyo. It's a good one. Mitus are, they're kind of the caliper that you can throw in your toolbox and it doesn't get ruined. Although you don't really want to do that with these. You want to kind of keep them nice and safe. I treat this about as good as I treat like a writing pen, like a nice one. I'll kind of keep it in a nice place and give it space and not stack stuff on top of it. They're very repeatable. These are sort of the nice ones that everybody uses. These are not the super duper duper nice ones, and these are not the cheap ones. You can get by with cheap ones. You can get by with super duper duper nice ones. These are just good. They're very, very good. I like them a lot, and I endeavor to take care of these. Anyway. Bada bing. So usually that step would highlight. If I click on the steps, it does highlight what was done. So this one, if I click on it, that highlights inwards. And it looks like the highlighting is what's the problem here. I think the night mode, going into night mode changes a lot of the visuals of the program. So this should be, instead of -3, it's -4.6. So that gives us a 3 millimeter cut into the material. Always out of batteries when you need it. Tip number 2 about calipers. Figure out what battery you need for your calipers. Oh, I would show you guys. Figure out what battery you need for your calipers and order spares. And bring them to work with you. But don't let anybody know that you have spare batteries for your calipers. Otherwise, people will be coming to you at all hours trying to get your caliper batteries. And my caliper batteries are very private, so I don't appreciate sharing them with coworkers. But yeah, the calipers are nice. Get the batteries. Always. It's just like having lead for a pencil, lead for a mechanical pencil. I'm not going to try to put this pattern in the bottom. I don't think that's something that I could really accomplish with a 3D printer. Although I could tell it for like the infill to do something weird there, but I think mostly what we want to do is just make sure that we did the right thing. Now, I could add chamfers until I am blue in the face. I could add little chamfers to all of the edges of this, but I feel like the slicer is probably going to do that. For the slicer, we're actually going to need to get Super Slicer. I need to get the newer version of Super Slicer. Cool thing about Super Slicer is that it contains all of its settings in the folders and stuff, and so when you upgrade, you can still get the portable version, and it'll just know what's what. So I need to look up Super Slicer. It will be the bottom surface, but it's going to be weird. Can't you do the hollow print surface? I guess so, but I don't think I'm going to do that. Is the right Super Slicer? I think so. Okay, where are we going? I'm going to the master branch. Where's our releases? I always forget how to download stuff, get releases, and all the little programming nerds will start giggling at you because you don't know how to download shit. This one, that's pre-release. Wait a minute. Pre-release. Holy shit, look at that. Dynamic overhang speed. Huh. I could probably play with some of this stuff to get some good results. Graph edition. You know, I don't know if I got the latest stable. Here's the latest. BIS edition. And then Win64. That's the one. All right. Extract to folder. I just throw it on my desktop. I'm too lazy. So this super slicer is now the latest version, and because, oh, let's do this. There we go. Hate it when it does that. Super slicer exe, bada bing. It should have all my settings in it. It should see CR10S, whatever. CR10 Rolly Cart, CR10S Clipper. Yep, that's the one. Okay, cool. So from Fusion, what do we do in order to get our solids out of here? Well, now keep in mind, I can chamfer and soften the edges of this thing to my heart's content. This is pretty square. I feel like the slicer might soften this up enough for me. I think the most that I would do is let's just hit the top edges here with just a little bit of a fillet, which is the rounded style chamfer. The fillet's not the chamfer. They're totally different things. I'm a mechanical engineer. Whatever, man. Let's give it a 1mm fillet. Now this looks weird. This is not what perspective things look like. Oh, never mind, it is. Perspective with ortho faces is the one that I like using. Some people stay in orthographic view, and somehow this doesn't break their brain. I don't know how this doesn't break your brain, because this isn't how perspective works. Orthographic view is designed for either a 3/4 view or for a face-on view where you're measuring stuff flatly. That's why the perspective is all weird. That's why things that get further away get larger. But that's not how perspective works. So if you go with perspective with orthographic faces, this all looks dimensionally sound. And when you go into just a face view, it snaps in and it becomes a functional view. So yeah, anyway, I'll give it that little chamfer just because of the bend of the metal on this thing. I don't think it's 1mm. I think it's going to be less. But we'll give this a print and just see how it meshes with everything else happening. And if we have to, we'll do the cut inside of here so that these faces bend inwards just a little bit. That might be necessary, actually, to be honest. Maybe we do the cut. Maybe we do the cut so that... Now, I'm going to start with this. I'm going to start with this and see if it works. And if it just works, there's no point in you know, rocking the boat. I'll just print 4 of these and completely replace all the legs of this thing. And then the legs will be little pieces of plastic. Put the logo on it as an Easter egg. It's too small for my printer to put a logo on. If it was larger, then yeah, I would totally do that, but it's way too small for that. I'm just wondering if I need to put a cut in the back so that I can actually bend these a little bit, because I think that's how they're installing them. Well, let's print it the way it is. So what I do in order to print this thing, first of all, I give it a snappy name. 3 foot should be fine. So tree foot, rename the solid, the body, rename the body to something. Right click on the body and then save as mesh. So save as mesh is going to create the thing that we can pull into the slicer. You can connect Fusion with like a slicing program, and I probably should, but I just make a file. I have a temp prints file on my desktop. Microsoft would have you put it in the 3D objects folder, but I don't trust them, so I put it into my own desktop folder. 3MF is fine. You can make a STL, you can make an OBJ. 3MF is sort of the more modern mesh file. So I just do 3MF, and I don't touch any of this stuff. You can model the bottom as a foot, like a footprint foot. I could probably find a picture of a vector foot and put that on the sketch. I'm not going to do that, though, because I don't trust my 3D printer. I don't trust my printer to do something like that. So 3MF, I don't mess with any of these settings on it. I just let it do its own thing. Unit type millimeters, structure 1 file. I think in millimeter it might mess up a little bit in some slicers. For Super Slicer just detects it and is fine with it. But 3MF and then save to my computer, users oh bother desktop, temp print, save. 3MF is a zip file with an STL and some JSON files and a photo of the model. I didn't know those were auto-generated. Huh. So, Super Slicer. How much of a basic bitch am I? Well, I go to my desktop, temp prints, I grab it, and I drag it, and I drop it. That is the extent to which I am able to use the file stuff in my computer. So the best axis for this to print on, really technically I could print from this back face here, and that might do pretty good, but then this would need support material for this overhang. My printer's not very good at overhangs. I think maybe this is the best orientation to do it in, just like this. So if I slice it, I would like it to do supports, build plate, enforcers, everywhere. Let's try it. Yeah, I guess that's all right. So it's going to build this little tower and then make it support that way. But this is what I'm talking about, like with the chamfers and stuff. The chamfers of 1mm chamfers are represented on 3 rows. They're going to barely be visible. This whole thing's going to look like crap. It's going to look like crap. But it'll be my crap. So what's our time? 20 minutes? That's pretty good. Here's the deal. My printer is a Raspberry Pi inside of kind of a custom base. So let's move the burn the subs cam so that we can see the printer. Get my cable over here. And we're just going to watch this 20-minute print. And we're doing it in gray, just because gray is an easier color to see. I'll have to mess with the camera settings in order to make this more visible. Move that out of the way. What is that doing there? Okay, the printer's on, but I don't know if it's reachable. Although it did do its BL touch test, so maybe we can get into it. I think so. I don't have any special settings. I just got normal settings. I think it is 0.3. So 369 makes sense. Camera settings. Properties. Figure video. And let's take up that exposure down. There we go. That's a little bit more normal. So I need to get into Octo Clipper, Octo Print. 0.3 is big for a 0.4 nozzle. Why does everybody have some kind of a criticism as to the system that I'm using? I don't understand why that always is the case. Everybody has a criticism, and yet I listen to you guys when I set up my printer. It's ridiculous. Shouldn't Octopi be coming up when I turn the thing on? I mean, it did its clicking thing. I don't know why that's not coming up. Try loading it again. That should be coming up. All right, what's going on here? This is still Firefox. Yeah, so I didn't... No, wrong view, wrong view. I didn't fail to turn it on. That thing's on. If I unplug it and plug it in again, maybe it'll reset the Raspberry Pi. Or maybe it doesn't remember the credentials. This thing has been powered on for a long time. Maybe I'm going to unplug it in the back and plug it back in. I think that might be the problem. I have a switch on this? I think I do. Check to see if there's a switch. Out and back. Yeah, oh, there's a big switch. Off. On. Oh, that was a specific switch for the Raspberry Pi. I forgot about that. I have a way to restart the Raspberry Pi manually with a little switch on the back. Well, I should probably give it like a way to reset itself, like make it able to activate like a relay or something so that it switches itself off. We gotta wait for the Pi to reboot. It's still doing its thing. This is the worst part about the 3D printer and the way that I set it up, is that it's a little bit fragile. And once I get everything working and talking to each other, you know, things work out. It's just initially the Raspberry Pi, when you turn off the printer, the Pi stays on. in order to preserve this intranet site. What happened to my foot? I need another one. Unfortunate that one of my 4 feet is missing. And so I've needed to 3D model one and print a new one. These aren't even rubber. They're straight up just plastic. So we're printing another one. Which one was this? I think we did real credentials on this one. Please remember me, even though you won't. Cool. It's very, very fast. It's very quick. What is happening here? Come on. Let's go. Let's go. Let's go. There we go. All right. Connected. I doubt that. It says Clipper standby, but all these are... So, okay, connect. And we get a serial number there. So if I go to this, and I hit BL touch down, thunk, and then I hit up, thunk. Okay. Cool, 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 cool. So that's ready to go. Everybody has criticisms about what I do, and yet you are the people that got me to do this. I am not in the business of constantly updating and upgrading every single thing I have and optimizing and maximizing and blah, 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 blah. I understand that Mainsail's great, but I still use Octoprint because I'm fucking lazy. And all you 3D printer people are so insufferable. Just send in a Bamboo Labs. Call Bamboo Labs and get them to send me a printer. And I can just plug the fucker in. And then nobody will have criticism. Same thing with IDEs for programming and for CAD software. Everybody has their little, why don't you use this thing? And it's like, whatever. I'm sick of it. All right. This Treefoot 245C, upload and print. And then burn the subscan. There's dust all over the bed. We'll just see if everything goes fine. Since day one, he had that printer. He hated us. Yeah, that's not controversial. I didn't want to get a printer because we can't even print stuff in 2 dimensions, let alone 3, with reasonable accuracy expectations. And then I got the Creality CR10S, and I started to get to know it a little bit. And then I hated 3D printing fervently. And then I worked with it more and more. And then I got a direct drive extruder that Wexo sent in, actually. And it was awesome. Things started to actually work. The direct drive head makes things so much more pleasant. And then this is a Frankenstein printer at this point because I've totally redone all of the solid stuff. I've connected everything with 3D printed parts that I built in Fusion360 using a CR10S model. And then I put a Hymeria, hernia front end, a hot end on it, with a CAN bus activated control board at the actual print head. So there's a lot of crazy modifications, and I actually think CAN bus might have actually died right now. Let's check. CAN bus every now and then. Exclude object define. What does that even mean? Okay, so we're still okay. Building up heat. No, we got through most of the Happy Cat print. When you get the CR10S, they give you a memory card with a bunch of stuff to print, and then they give you this tiny little whimsically small spool of plastic, right? And so you put the spool on, and you say, what am I going to print? You look through the list, you say, oh, Happy Cat. Nowadays, that didn't exist back then, but nowadays, if you look it up, you can find a bunch of people who tried to print the Happy Cat. There's not enough filament to print the Happy Cat. You get about this far up the base, and then it runs out of stuff. But when I got the CR10S, that was the first time Roboz was playing a computer modifying game, and he rage quit. So he actually raided into my channel. And so we had like 1,500 viewers, and I had just the thermal camera view of the printer doing its job. It was kind of like one of those victory lap streams where we actually used the thing that we endeavored so hard to engineer. I don't get a lot of those. Now it's just going to wait until the temperature is stable, and then it's going to do all of the measurements. There it goes. I'm going to close some of these windows. So we used a capacitor calculator for the emote thrower. And we know now that the capacitors with an 800 ohm resistor, the capacitors will charge to 100 volts in 4 seconds. That's not good enough. Actually, I think that might be a discharge calculator. Whatever. I figure what is it? 4 seconds to charge up. So I put a 4-second delay on the ideal light so that if somebody put an awe emote, there would be a 4-second delay and then the ideal light turns on. Turns out 4 seconds is an eternity. So having it charge in that amount of time is not acceptable. What we're going to do is put in the circuit a bypass transistor. And my hope is that the bypass transistor is not going to be blown up. Hopefully this isn't the blow up your transistors transistor right here. So this portion right here, we have an 800 ohm resistor. So the power supply is going to go through the 800 ohm resistor, and it's going to be using 125 milliamps, which is more than the 80 milliamps. But that'll be able to discharge its internal capacitor, which discharges in like 0.0005 seconds. So that will go through this and discharge that capacitor. We can then drop the hammer on it by closing this transistor, and then all of the current that it originally was able to provide to the capacitors, it'll provide. Before, if you remember, it just went zoop. It was like 1.5 seconds to get to full charge. So we're gonna retain that, but we're gonna keep it from discharging that capacitor through our transistor and blowing it up. So it's probably more than 600 milliamps because it turned that into a little molten piece of silicon slag. And we can build that probably on Thursday. We've got probably a little more than 20 minutes for this print, and then we're going to size it up and do modifications. We're taking this iteratively. We're taking an early draft of our design, and we are going to measure it up against what we're doing with it. That's why I'm using gray filament, because gray filament is a little bit more visible. All right, so it just did the bed mesh. I don't know if it really uses the bed mesh. Does it really use the bed mesh? I don't know. I have it doing the bed mesh like all the time, but I've seen people drop the bed meshing thing, and they've had a perfectly fine time of it. I've also seen people do like 1 in 5 prints. It'll do a bed mesh and then use that. But I think we put on all the G-code in there properly. My bed is mostly taco shaped, and I don't know why. It just has sort of a divot in the middle. Okay, so is it sticking to dust? I don't like that little thread that's coming off of the hot end. So it's going to do a couple layers on a little skirt here. Hopefully it'll capture that booger that it's got going on. That booger is trouble. I need to add a little tiny LED to the hot end. That's one thing that we need to build, is an LED on a stalk, because we can't really see what's going on here because of the shadow. I do have big drop lights that I can put in, but they're always kind of a hassle to set up. I'll figure something out. What do I have like on hand here? I have those work lights. Maybe I can put a little work light on it. Hold on. Let's find one of those little sticky work lights. I think I've got them over here. Oh, actually, wait a minute. This might be perfect. One of these little rechargeable magnetic johns. Motion detected at the front door. Okay, so it's made out of aluminum. So where can I put this? Everything is aluminum. Just lean it like that. That is the worst lighting I've ever seen. I need to be like right here, but I can't hold it to here permanently. Behind the camera. That just doesn't work when I put it behind the camera. All it does is illuminate reflective surfaces. Actually, that does a little bit. That's a little more visible. It's a little more blue, but yeah, PETG sticking to the nozzle is a hassle. It's annoying. If you get through your first layer with PETG, though, it'll do you good. And every single problem I've ever had with PETG, I have solved by raising the temperature. And chat hates that. They hate that. Whenever I have a problem with PTG and I ask my Discord, they say, oh, you should lower the temperature and try this, and do that. No, I'm going to raise the temperature. And then I end up solving my problems. PETG go burr. Dry your filament, dry it, dry the filament. Do this, do that. Nope, I'm gonna raise the temperature. And it's always worked. Except for the times it hasn't, but I don't remember them. Yeah, it was a stock CR10S. Oh, sorry, I misread that. One day, maybe I'll go to Mainsail, but I hope that one day I can be big enough to get a, like, one of these 3D printer companies to actually pay attention to me. Prusa doesn't give a crap. They'll never give a crap. Oh, I'm gonna cough 1 second. And Bamboo just crushes me under their heel. They're too big. They don't notice me. I'm just this little guy. Maybe we'll raid into Robots today because he's playing Obensour. Celia, have you played any Nucleaires? It is kind of an amazing game. Fatanon was really big into that game for a little while. The Creality K2 Plus. I haven't kept up with Nucleaires. It's awesome. It's a really cool game. Hold on, let me pull this up. The Creality K2 Plus. I'm losing my voice. Oh, so it's one of these. Yeah, all these printers now are all their own kind of thing, right? So multiple filaments like usual. Oh, our Encore sale. All kinds of stuff. Oh my God, somebody printed a castle. So this is one of those enclosed printers that has multiple filaments, and basically everything has been solved. And you can just hit Control P on these things these days. And the printer will just poop out whatever you want. Their laser engraver, that seems pretty cool. You haven't played it? So Nucleaires is still being worked on, but it is a game where you have to run a nuclear reactor. And by run, I mean you're in the control room and you're flipping buttons and switches, and everything is modeled off of an actual nuclear reactor. I learned about it through Tomato, when Tomato played it the first time. So I bought the game, and we had a stream where I played it. You were there. You just don't remember. It was the stream where I hopped on a train to avoid the lawsuits that were inevitably gonna come from that. I ran from all the congressional hearings that I would have to be in after failing to completely run the nuclear reactor. Because it got like a little squirrely and unstable, and then things went really wrong. But now there's so much more to it that you can actually enable chemicals, and you can have, yes, you can have a Chernobyl where you have xenon poisoning of your reaction. Pretty cool stuff. I gotta look into it. I gotta play it again. Yeah, the K2 Plus, it's crazy. All these printers now are just like a solved thing, but I don't have the money for a printer these days. You know, I've been scrapping. I've been scrapping it. That's what this printer is all about. I spent the money personally when Burn the Subs was more of a thing and was more popular, and I was able to pool thousands of dollars. I can't do that anymore. But we kind of have gone through the upgrade path on this one, just, you know, piecemeal. So while this is like a pretty nice printer, and it's got expensive nice things on it, those expensive nice things were like one at a time over the course of years. So this thing is shaping up pretty quickly though. The tune on this is from that 3D printer tuning website, and they do a really good job. The only thing left to do with this printer would be to add accelerometers to the axes so that it can do a little bit of compensation for the wobbling. I've yet to do that. I would like the game is Nucleaires. It's Nucleares. I would like that to be a little bit more like what is it? Signal Simulator? Which one is that? No, Voices of the Void. There we go. Although Voices of the Void has that sort of Half-Life 2 kind of jarring sound effects that are like a little harsh. But I like the whole like dirty research facility that you have to kind of refurbish. This should be like a dirty nuclear energy facility, even though that's, you know, nuclear energy facilities are not allowed to become like that. At least the operational ones. CR10S was top notch for a good while. It was first when Bamboo came on the market. Other makers started to go for speed too. Interesting. I mean, it's a very basic design. They kind of boiled, Creality kind of boiled the printer design at the time down to its component parts. But nowadays with enclosures, it's a totally different animal. So they've now all your top-notch printers have all the filaments inside of it where they can be kept dry. And it's just like sort of this thing where you hit print and then you pull your thing out of the cabinet when it's done. Just kind of a change in the landscape, I guess. And, you know, following in the footsteps of, crap, what was that? What's that DIY printer called? The really fast one? Everybody's kind of following in their footsteps. It's all coming together. Voron, there you go. Yeah, the fetish one. It's all coming up cake. Now it's going to be important for me to let this cool. Basically, when the PETG prints are done, they are kind of the consistency of like clay, like hard clay, but still they can be warped if I go too hard into the paint and I try to grab this with my hand. So we let it cool with the bed, and because the bed and the plastic are different materials, they expand and contract at different rates. So when the bed cools, the glass is going to contract just a little bit, and the plastic's going to contract about 3%, and that will make a kind of a schism in the distances that those little glass dots are attached. And so the print will suddenly go and it'll fall off. I can basically invert this printer, and then when the print's done, it'll just fall. Which is something I've wanted to do. Nobody uses the 3D printer, goes and buys Voron. Yeah, that's... But I mean, so what I mean is the design, going with the, you know, the XY axis and the way that it's designed, and the sort of the bed in a cabinet thing. What am I 3D printing? It's a foot. Isn't that clear that it's a foot? Doesn't it look like a foot? It's definitely a foot. This is a foot for a Christmas tree stand. And if all goes well, I'm probably going to be printing 4 of them. But this is our initial... You know, you stream for a while, and then you notice that there's holes in your brain. And the holes in your brain don't get better. They just get bigger. Bigger holes in my brain. So I look for words to speak with, and I go, oh, there's a hole. Anyway, trying to get through basic language tasks. Maybe I can assign an AI to say the things that I need to say in a really sort of dog shit, boring way. Yeah, this is a foot for a Christmas tree stand. We are missing one. Don't know where it went. So we took calipers. We humped the thing with calipers for a little while. It's got a lot of really annoying angles. But I think we replicated those pretty well. And so this is our initial print. This is our version 1. And we are going to iteratively compare this to the foot that exists on the tree and see if this is an appropriate stand-in, in which case I will be printing 4. Now the foot has a little texture pattern on the bottom of it. I could probably take a triangle file to it and make that pattern. I don't know. I made a small Voron printer myself and used 4 days on that damn little thing. I feel like I can fit. I feel I can't fit a Raspberry Pi case on the print surface because it's too small. That's weird. I don't know. Yeah, this is Creality. The CR10S has a nice 210 by 210 millimeters. Is it 2 or 3? I forget. It's a big bed. We do all kinds of cool stuff. Oh, there's an airplane crashing outside. I don't know what it is about my location. I think there's a small airport nearby, but all of the airplanes that fly by here are just, they sound like they're fucking crashing. We're like there must be I think there's an airport like out west of here as you get towards like the farmlands of Philadelphia, of Pennsylvania. But man, like every now and then I'm walking the dog and I'm like, where is that fucking airplane? I would get one of those. We've tried actually before to do the airplane scanning, so you can see like where all the local flights are in your area. But that's a little bit doxing. So I don't want to go further with that. But that's a fun Raspberry Pi project. You buy one of these software-defined radios, which could be as simple as buying a sound card for your Raspberry Pi. Plug it in, and you plug that into an antenna. One of these multi-frequency antennas, and then the SDR, the software-defined radio, can scan all kinds of different frequencies. One of those frequencies is the one that airplanes use to communicate with one another. So you listen in on that frequency, and you can get all that data out of it. It's relatively easy to install. I've wanted one of the nicer SDRs, but they're kind of expensive. Just a little bit expensive. We're almost there. How close are we to this thing? Let's check with OctoPi. Octoprint. 75% of the way through. We should have about 7 minutes to go, an excruciating 7 minutes. I think on Thursday we will try this modification to the circuit for the emote thrower, and I think that should get good results. We can see basically what I can do is I can build this section here. This is the new stuff. What we have is a current limiting resistor to make sure that this power supply isn't overdoing it. It'll be overdoing it, but not super overdoing it. We're going to be getting 125 milliamps through this resistor, and it's going to be limited there. And then I can activate this one and see if it blows up both of them. So we can start out with the current limiting resistor, watch it charge up over about 4 seconds. So it's like 1, 2, 3, 4, pop off. And then I can try sending it the bypass, so it'll go 1, 2, 3, 4, or 1, 2, 3, or whatever, 2 seconds or whatever to charge what it was doing before. And then it'll, if hopefully setting off the second one won't blow it up. And then of course I can use this again to isolate out so that we don't have 9 volts sitting on these things. And so the power supply isn't asked to give it full current when we discharge it. I think that'll protect my transistors and keep this thing from smelling funny. I have that very setup, except I connect the SDR to my Mac, not a Pi. With the Pi, you can throw it up in the attic. And then you can throw up in the attic. Nobody knows what'll go on in that attic. So that's what I was going to do, is throw it up in the crawl space. And then I would have my SDR at the top of the house, able to scan the whole horizon. But for some reason, I don't know, RF just doesn't get through these houses. I don't know what it is about the construction of these fucking houses, but RF does not penetrate it at all. I should move the camera to the other side. I mean, all the filaments and stuff is a kind of a view, but I think I need to focus more with burn the subs on this camera. Oh, I didn't do that because I don't have the distance. That's right. It barely gets to this. That's right. I remember now. Yeah, and I would like to move out a little further out to give more of a view of the printer. You can see the screen and stuff, but it's not totally worth it. And then the other thing that I would love to do is give that printer a glass top, because all the electronics inside of the printer are a work of art. I worked very hard on putting all that stuff together. There's a lot of technology in a very small space, and it's all on DIN rails. The case is actually an aluminum case, and it's built for not high def, audiophile radios. It's the same sort of concept behind what I built my power supply with. This thing over here, that custom power supply, you can buy the panel, you can buy the thing in the back that's actually driving it from AC. So you get the big power supply that makes 52 volts at a bunch of amps, and then you get the 52 volt capable whatever it is, bench power supply control unit. And then from Easy Hook, I got the terminals. And of course, that's just, regular switch and everything. And then I took the panels and took them to the milling machine and milled them all out as precisely as I could. So there's mistakes. And it looks like crap. But anyway, it was like a little milling project. And then you put everything inside the enclosure. Bob's your uncle. You have a nice super duper high current, high voltage benchtop power supply that's more capable than the Agilent. But I brought the Agilent back because the Agilent's much more accurate. So it's good for the musical stuff. Sometimes projects are slam dunks around here. Tom thinks his little voice changing button was an absolute slam dunk. I got to learn a little bit more about creating a device like a button. It was simple, it was easy, threw it together, and it super duper helped out Tom thinks. Run his stream and not injure his foot by pressing on a foot pedal. Instead, he has a little button on his desk now. The power supply was a slam dunk project. I got to do a little machining, not all that accurate, got it good enough, and put together a benchtop power supply that I've been using for 6 to 8 years now. So every now and then we find these projects that are just completely awesome and get everything done that I want. And sometimes the project kind of lingers for too long and gets a little too complicated. So got a couple of those on my belt. Yeah, that too. For slam dunk project, redeeming a fart. And the first thing you type is a number, and so it goes through. That's awesome. That's funny. If it's anything but a number, it should. Oh, okay. So it's not the first. So if you say for slam dunk project, that's not going to set off fart number 4. That's going to set off a random one because of the way I've done the node red. Because of the way that it is. Here, like this. So your message comes through on the fart redeem, which is down here. So point redeem, if it says it's a point redeem for a fart, then it'll set the message payload to be the reward message. So for slam dunk project is on there, but then we go into the switch, and the switch said if it's between 0 and 9, go out number 1, otherwise go out number 2. So if it goes out number 1, it goes straight to the fart box, and it'll set off your numbered fart. If it's anything but, we set the message payload to 0, and then that goes to the fart box. And 0 is random. So there's no way to fool it. It'll never, ever be fooled. I think Tasmota does a lot of the good error handling too. So we've gotten to the point where these two are separating from one another. So it's hopping over to one area and hops over to the other. I guess I could improve on this if I use one of those rubbery filaments, because these are a perfect candidate for rubbery filaments because you don't want it to deflect too much. I thought you were scrapping everything but the first word. Nope. Nope. I could do that. I could set the message payload to be the first character. I'm not sure how I would do that. I think maybe it would be another one of these. Set message payload, low and global. See, I could have it search for a number to replace it with a number, but I don't think that doesn't really work. I think I would have to use a function or a regular expression. But I think it's good the way it is. Yeah, a more microcontroller-y way to do it would be to just take the very first thing and then throw the rest out. And if it's a number, then act upon it. Well, that would mean I would have to scrape it, check if it's a number. Check if it's a number is just the same thing as the switch. So So that would be fine. I would still be able to use the rest of that flow. I would need to remove all but the first character of the message payload. And I think that would be much easier to do in functions instead of using, you know, change and switch. That's a property based on the template. This is the payload. Payload. I don't know. I'm not read up on Node enough to know how to do that with the nodes. I know in a microcontroller it's super easy to do that. All right, so that looks like a terrible print. It's not that good. My printer is not great at doing small stuff. Good enough for a Christmas tree stand, though. What I'm waiting for now, and this is just a property of my printer personally, is when those two lines cross, then it is relatively safe for me to go over and try to pry the print up. And so what I can do is spritz it with Windex, and the Windex will evaporate, and then the two things will change sizes from one another, and it'll force the print off of the bed. I don't think we're in too much danger of warping as long as things can cool just a little bit. What's my BG doing? What's my glucose level doing? Motion at the front door. Motion at the garage. Hey, look at that. My sore throat is going away as my glucose level asymptotically approaches normal. Waiting for things to cool. Want to give it just a little bit longer so it can solidify enough. Things like flat panels are terrible at warping, so I really give it a huge amount of time. Wait, what about the contains block? Message payload is between 0 and 9, otherwise. Value reads has key is between. Sequence rules, head, tail, no. Is empty, is not null, is true, is false. Yeah, I think I would have to use a regex. And I barely know how to program regex. It's crazy. Regex is nuts. All right, I'm going to go scoosh this thing. I'm going to hit it with a spray bottle. We are not quite there yet, but I did hear a little tapping noise from it. I'm going to force the issue early because I'm streaming. Otherwise, I would forget it, go take a piss or something, and then it would be at the right point. But since we're streaming, I'm going to try to get it off of the bed right now. So I get my spray bottle over here. Where's my, there it is, it's against the wall. Take a big steppy. Oh my God, it's like 70 degrees out. Jeez. Just get by the window and realize it's like nice. I should be walking my dog. I'll do that after stream. Okay, that didn't work because it's still too hot. Hey, give me this. Hey, hey, you awake? Hey, hey, give me this. Give me this. Hey, hey, bud. Hey, give me the print. There we go. Ouch, it's hot. Get this out of there in case we start up another print. Okay. Now let's see everything that went wrong. Every single error laid bare before us. Get these things out of the way. Those are the angle blocks and stuff. Okay, so like I said, my printer is pretty rough around the edges. This is a relative facsimile of what we have. I know that my sizing is good though because I have measured my printer and calibrated it. It's funny how it's kind of like pixelated with all the angles in it. Let's get these out of here. Let's see if this can be good enough. So a little pair of pliers. Actually, this is a good job for these. The little channel locks that I got. Yeah, perfect. So because it's PETG, it's a little rough with the support material. It's kind of a little bit difficult to work with. That's why having channel lock pliers and stuff is pretty good. I'm still gonna have to stick a screwdriver into that, I think. Yeah, okay, so flathead check. Get in there. Try not to have the flathead penetrate my body in any way. The worst part, like when you're removing support material, things can just pop off and you can accidentally stab yourself with the things that you're removing the support material with. I've had that happen several times and it's not fun. So I always kind of want to be a little cautious when I'm doing this stuff. I already have to replace a foot. I don't want to have to replace a finger. And I've got like a ton of separation on the supported layers, which means usually the supported layer comes in pretty crappily. It's pretty bad. I've done the best I can with PETG. But we favor strong prints here. Look at how wobbly. Look at this. I don't know if I need to look at my printer or something, but look at that. Woo, 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 woo. What I'm looking at is that these are wavy. Thingiverse. You got to print it for yourself. That was on Thingiverse, and I was like, I got to have that in gold on my desk with pictures of Spider-Man. You can also find the sexy Waluigi on Thingiverse. Pretty cool. Cool little print. So I guess you could get the STL and send it like Shapeways. That would be a lot. Find a buddy that has a 3D printer. It's kind of weird because of the layered nature of the 3D print. We've kind of made a pixelated version of the foot. Oh, and that was a bad measurement, which means, is the angle correct? Kind of seems like it is. The angle and the distance is going to be different if this measurement is not good. I prefer this over the sexy Waluigi. You know, each their own. That looks off. I think our measurement there is off by a bit. Maybe not. Maybe because the angle looks largely the same. This may be close, like near enough. This makes no difference. Maybe that may be falling under those lines. So let's see how it fits onto this thing. Does it need to flex in order to install? Seems like it does. Okay, so the flexing of the ends is entirely necessary. Well, consider myself a little bit more educated. Ah, there we go. The angles are, they're close actually. I think they're actually okay. Of course, I bent the metal installing it, so. Yeah, no matter how thoroughly and carefully you measure, something is always off. Because I'm not a mechanical engineer, you know. All right, so in order to fit in without that being bent, I think we're on the right track though. I think this is okay. And that 3mm overhang, yeah, that needs to be narrowed a little bit. Okay, so if we do all that stuff, we should be in good shape. And how about the front back fitting of the, it wobbles a little bit. I think that'll be okay though. Measure twice, print thrice. Yeah, okay, so let's get some of these. Damn it, come on. Oh my God. Well, at least they didn't, it's not in danger of falling out. I don't need to soften the front end, do I? No. And if I print this in black, it'll blend in. So if this is a little bit more of an angle, I think that'll fit more accurately. Well, it's good that there's a little standoff. But The question is whether or not these things actually contact, but I can't get this thing out. Get out! Shit. God damn it. In order to aid installation, I need to have this thing bend in the middle. There we go. Oh, don't get off my calipers. Okay, so what was the distance at the top there? We said 3 millimeter. Yeah, that's 2.7. But when we made it 2.7, it's like way larger. Okay, so that must be a 2.6. Let's make that a 2.6. All I got to do is go back into the sketch 2. It'll rewind the time so that none of those extrusions have taken place, and I can make this, and here's the danger with this, I can make this 2.6. Now, what's locked down and what isn't? It seems like everybody moved just a little bit then. So my measurements might all be off by a little bit, and since they're all based on different parts of the geometry, things are going to get weird now. Our gaping hole over here is now in a slightly different position because this distance has changed, because this angle has changed. So everything is affecting everything else. We'll just see. I mean, this is probably close enough that it's okay. I need to also put some kind of a cut in the back of this thing. Now, it doesn't need, I think it should stay on the axis of the printer, so the printer isn't asked with printing things kind of weird. So if I just make a cut from the back here, I think that should be pretty good. It's gonna meet this at a weird angle, but the whole point is that these become like two separate pieces that can pinch together. So I'm just gonna make like an informed guess, and I'm gonna add another sketch. Too many sketches around here. Create sketch. Create the sketch. And then I'm gonna determine a thickness for this thing. If I make it 3, those slots become holes. So maybe we make it 4. And I'll just do it twice. The 4 on this end. Now is that actually locked down? Yeah. It helps to grab and drag your points sometimes, because every now and then it'll not put in a constraint that you thought you put in. And then what distance from the bottom? So I'm going to use a 3-point rectangle. I can just do a line from the bottom and use a 3-point rectangle to define the rest of it. Okay, so line from the center of the bottom, that's a construction line. So I hit X to make it construction. And we're going to go up. Let's go 2 millimeters up. That will make the base a little bit flexible in this area. So if we're close to this at the bottom, when we flex those 2 posts, it'll flex at the bottom of the posts. And we'll just see how that does. It's going to be a lot thicker than the original one, but the plastics are different and they're made differently. Oh yeah, this should be construction. Wait a minute. Get out of the tool. I don't know what that thinking thing is. I don't know what it's thinking about. What you thinking about, computer? So 3-point rectangle from here and here, down this way. Oops. Make it solid. Connect it to there. And then the thing about 3-point rectangles is that they often don't listen to you. See that? It didn't listen to me at all. Why didn't you listen to me? So what am I constraining this with? Midpoint? There. Jeez. The 3-point rectangle, I don't know if it's broken or something, but like when you bring it to that point, it will go to the distance to that point, but it won't lock it in any way. And you kind of expect it to lock in. So you have to then go back with constraints and lock it in. I got a blood glucose on top of me. BG. Oop. Okay. Finish the sketch. So extrude this, and then I'm going to go to object. To object and just select this line. Can I select the line? I can't. I'll just go to this thing here. Boy, this thing is looking real awkward these days. I could make that hole go all the way through. I guess I probably should. I mean, it doesn't matter if it does, although it's going to create... Nah, maybe we should just make it go all the way through. So I'm going to go back to my extrusions and actually get rid of this one. Get rid of the first one. I want the second one to be the master one. So if I get rid of this one... Nope, that's the wrong one. Get rid of this one and just right-click and go to delete. Oh my God, where is it gone? No! And go to the second one, which is over here. And just take that through the whole thing. There we go. I saw Lawrence playing Deus Ex this weekend. I remember Deus Ex. I remember that game. I never played it because of the expectations. Everybody thought it was going to be this amazing game. And then it turned out to be really bad. But I don't know. I was kind of vibing with the game. I thought it was pretty cool for that era of gaming. I guess other games of that era were a little bit better than Deus Ex for sure. But I don't know. It seemed to have its charms. And also, for some reason, the cyber future is all metallic. Like, everybody's wearing gray metal. It looked like this thing. And biological. All right, so let's save as a mesh. And no settings changes. Just do it straight up. This thing is so small that a lot of little chamfer function, like little chamfers and softened edges, aren't really going to come through in the layers. They're not really going to be that visible. So I just forego them and let the slicer do all that work. So 3D view, delete a part, go back to the folder. This is my workflow. It may be different than yours, but it works for me. So tree foot into there. You loading a new project while the current project is modified. Do you want to save users? No. Just cancel the saving. What are you doing? Well, I guess I should say no. I don't like it when it does this. There, jeez. Okay, supports everywhere. Infill 18. Oh, that's right. This one is right click. Do I want to change anything like the surface that it's printing off of? I don't think so. I think we just go with it like this. So slice it, and that's going to be another 21. We've added a minute. What happened is I created all these inner geometries that are going to add time to the print going all around, to the print head moving all around. So upload and print, and then we're back over here where everything is going to calibrate and heat up. Did that BL touch just move when it bumped off over there? Huh. I don't like that big old thread hanging off of this thing. I'm going to go pick it off with a pair of tweezers. Got these long tweezers. Oops, I'm stuck on my stool. So yeah, we'll go back to the high voltage circuit on Thursday, and we can see whether or not I blow up any transistors. That'll be fun. And that may finally finish the electronics on that thing. We can start kind of working on putting it into something more, putting it into a frame where I can kick the emotes properly. These are not very strong. Oh, there we go. Give me this loop right here. Jeez. Gotta wait for the hot end to heat up, I guess. There's a bunch of mess on the printer right now just from not keeping up with it, letting it kind of sit for a week, month. This will be good to get done. I can load up the black filament and get these all printed. Out of a non-rubbery substance, it'll be a little bit slidey. And let's check to see that we are not in an error state. We good, we're just heating up. Oh, this is, no, this one? No, this one. Flipper. Exclude object define. Start, end, start, end, start, end. What is that? Is that something in here? Maybe there's an update that I need to do to Clipper because it may not be recognizing a command. Exclude objects start and end. During printing, getting the same error that I am. Hold on, I'm going to click here and then move the mouse and make sure this thing doesn't prompt me to log in. Okay. Label objects turned on in Super Slicer. Which one is Super Slicer? This one. Label objects. Where the hell is that setting? Where's the setting? Print settings. Printer settings. General. Custom G code. Oh, that's fine. General. Label. Label. Variable layer height. No. Wipe while retracting, that's all that stuff. Custom G code, I don't think has label objects in it. Why is it no matter how thoroughly one measures something? Oh, I bet we already got that one. It's how Clipper knows each object on the print surface, so if you fail, you can click it in main sail to turn the printing of that object and finish the rest of the print. Oh, that's interesting. Well, but in Super Slicer and Clipper, it's unnecessary, so I need to turn it off. Print settings. Overhangs, advanced, perimeter first, arcane perimeter generator. What? Infill, skirt and brim, speed, width and flow. I don't think it would be in here. A wipe tower. Nothing. Huh. See, it's so hard to find the stupid setting. Certainly not in filament settings. Yes, okay. And then I guess ironing is also in here too. That's neat. Oh, wait, I've played with that before. Yeah. Nice resolution, base height, first layer. Yeah, I don't know. I don't know where the setting is. Oh, is it in the slicing settings? No, that is the slicing settings. Inches, world coordinates, blah, 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 blah. Your tennis modified. Printer. Bed shape set. G-code flavors Clipper. Supports stealth mode. Remaining times. G-code precision. Processing limit G2, G3. Then formatting illegal characters. Yeah, I don't know. I don't see the setting. Oh, magnifier. Oh, is that? Where's that? Where are we? Where am I looking? I feel like an old man looking for. How do I open a PDF? Label objects. I like how it does the little petulant arrow. It's an output options. Okay. Boop. Cool. All right. So any subsequent. Now, hold on. Where do I save? Save this. So I wish I could put these files on the file server, because that would let me have one file setting for everybody. I'll probably have to transfer these to the other computer, or I'll just run into this problem again and reset it again. At least I know now. Communication error while talking to your printer. What? This is what happens when it measures the bed with CAN bus. It can sometimes time out like this. So I guess I'm going to restart everything. We'll just restart Clipper. Hopefully that clears the errors. And then we got a firmware number. So if I do BL touch down, oh yeah, I see nothing. BL touch up, printer is not ready. Ugh, it needs me to like clear the thing. Let's see. Home it? No, it hates that. Printer's not ready. Clippy software is attempting to connect. Please retry in a few moments. Restart Octoprint. Reboot the system. Just start over. Start over. When there's an error like that, everything goes to shit. I need to find a better procedure for resetting that, but now I just need to wait until this thing figures itself out. It unfortunately, sometimes the CAN bus can time out, and I don't really know how to fix that. I think I need to update everything. It's been a couple years since I've had this problem as a regular thing. When it's doing the bed leveling will take a long time, and so CAN bus can be like, hey, is anybody there? And then everything goes to shit, and I have to do this series of little restarts. Generally, when I have trouble with it, I just pull the cord and just restart everybody. Actually, we can regenerate that code so that it doesn't create all those error things. Oh no, but I need Octoprint to be functioning in order to send it the G code. Yep. Still 21 minutes. Hit reload. Clipper standby. Connecting. Oops. BL touch up. Cannot update MCU config as it's shut down. What? Reset the firmware. I just heard the BL touch go up. BL touch down. BL touch up. Okay. So then what I'm going to do is go to Super Slicer. Super duper slicer. And I'm going to send this, upload and print. There we go. God, I can't believe I forgot how to use Super Slicer. I forgot how to use it. I didn't know what to push. I felt like such a boomer. It's traumatizing. So I have to do a couple different things. First, it homes itself. Then it does a diagonal, not a diagonal, but like a horizontal test by going one side and then the other, because I want to ascertain whether or not the two z-axes are synced up with one another. And the funny thing is, with the z-axis, the way that they designed it is to have this big extrusion rail going from one end to the other. Now the metal, the bearing, upgrading to the linear bearing, I could have just had the linear bearing be the axis, because it doesn't really need any more rigidity than that thing offers it. But with the original design, they were using the extrusion rail as the bearing. So you'd have rollers on it, which I despise because they melt. But the rollers on it are all well and good. The two connections to the vertical axes do not allow for any adjustment of how diagonal it is. So if you don't have the BL Touch do what it's doing right now and measure how diagonal you are in relation, it will spring into its original position. So right now it does that, and then it does a very minor correction for it. And you can do the correction one after the other, and you can look at the numbers. They get more and more accurate each time it's measuring it. But then when you turn your printer off, it springs back into being where it was, because that extrusion rail is relatively rigid, and the attachment points on either end are really rigid. It's two holes that don't allow for any sort of twist or anything. So if they assemble it and it's a little bit crooked, you're stuck with that forever. And oftentimes it's such a small, minor, little difference that it does not make that much of a difference. It is such a minor distance that it doesn't make much of a difference in your prints. But I was running into all kinds of problems, so I discovered that there is a specific distance measuring for the bed that allows you to compensate for the two screws for the Z-axis being off. It is kind of excruciating to do this entire test every single time we iterate. Although usually this is where you go and get a cup of coffee and use the bathroom again. You go sit in a stall and check your email. This is another 20-minute print that we have to kind of sit through here, but I want to make sure that this first layer goes in just right. Oops, over here. Have anything else going on today? What else was I going to do? I got to remember. Doing my taxes was such a big deal. Finally finished it, although I owed Pennsylvania quite a bit of money. I don't mind paying for schools and roads, but man, I don't have the cash to begin with, guys. Or are you taking it from me? It's not actually that rigid. It flops around from run to run because the heavier side, or the side with less friction, drops more. I'm talking about the Z-axis tilting. And when I would do the correction for it, it would spring right back to where it was, because none of the stuff in there can support any tilting. Because it's attached at 2 points on either side, and so if you try to twist it and correct it, it just wants to spring back to where it was. Maybe that is caused by the Z screws allowing it to fall. Yeah, that's exactly what we just did. We did that before doing the bed mesh. We measured right, measured left, and then it corrects. But if you run that multiple times, the numbers go down, so it gets more and more accurate. But then you turn off your printer, and it just goes right up back to where it was. But that was one of the things that I kind of corrected with the redesign of all the brackets and stuff. So it actually, oh, mine was returning to the same number every time. It was crazy. Hey, what's up, Foob? All right, come on, first layer, go on, smooth. Let's go, let's go. The big breeze from outside. I guess it's a lot warmer today. There's going to be a lot of wind. Looking good. It's funny, these they must have switched from a more rubbery plastic. These must have been more rubbery. Adjustable end stops. Oh, so you just smash it up against the end stop and it'll correct? Yeah, all the BL Touch stuff is a little excruciating. I kind of wish that laser distance finder was accurate enough for 3D printing. If that little thing was accurate enough, that would have been awesome. You just have this thing use a freaking laser beam and just go over your whole bed. Zip, 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 zip. We're done. We got the mesh. Oh, when it's switched off, it rests on the stops. That's pretty neat. Yeah, I just have it go through this whole calibration thing, but it's like 10 minutes to get through. I don't think it's that. I think it's like 2 minutes, but still, it's excruciating. All right, this is a 21-minute print. Yeah, so I don't think, it wasn't really sagging. It's that what's happening is you have a rigid connection here with something like 2 bolts that are tight. And then you have the same thing over here with 2 bolts that are tight into a metal plate. And so although it can move a little bit with the bearings there, it wants to be in a position, right? And so if you correct it, you're putting pressure on all that stuff. And when you release, the pressure will release and the thing will just go back to where it was. It's like a spring bar. So what really needed to happen is if I were able to access that hardware, which on the CR10S, you can't get to the bolts that hold up that frame rail without going in from behind. So I had to drill an extra hole in there in order to get to the axis in general. And then you would do the test and have it level itself, and you release the bolts and then tighten them up again. And that would lock in the position of it being as flat as possible. Something I haven't done. Yeah, that's what I had is the roller version, and then I put linear bearings on it. But I think it can still do stuff. I'm not sure. Up to 5 degrees. Jeez. Inexcusable. The linear bearings didn't necessarily solve that issue, although it probably has its own forces on it that are making it be a little bit weird. I 3D printed all of the bracketry, designed it in Fusion and then 3D printed it, and then put my printer back together with all the new stuff. And I think it's better for it. I don't know. I'm not sure. Those rollers would get real bad, though. The way that I used the printer and letting it sit for months and then coming back to it, it took a little while. Sorry, it would get damaged over time. And I think maybe like Windex spray would get to stuff. And I don't know, the Delrin rollers kind of turned into cheese after a bit. So pretty much the big change between these two is that we narrowed the top here, which changes some of the geometries. And then we put a big cut in the back of it so that this can bend in just a little bit, hopefully not break, and then install into the sheet metal that it has to install into. So I don't have to bend the sheet metal, and it fits snug enough. Steel on aluminum has interesting heat properties. For the, oh, see, for me, it's actually linear bearing to plastic, and then plastic to other stuff. Like, it's not steel on aluminum. As you can see there, that it's 3D printed bracket that it's actually, well, steel on aluminum, that's an anodized aluminum, so that's not going to be reactive. And then, yeah, there's no real place that steel is directly contacting. Away we go, printing out the little U shape. So that's a Hymeria hot end with a CAN bus thing on it, the Blue Tree Tech or whatever, CAN bus hot end. It actually has, I think it has an accelerometer on it, so I could probably access that with CAN bus. That was a cool upgrade, the CAN bus stuff, because you only run a couple wires all the way back down to everything else. And then I've got a 120 volt hot end, bed, 120 volt bed and a 24 volt hot end. And then I use this Creality coated glass plate. It's got these little circles of glass that are exposed. I see the difference in thermal expansion. Oh, are you, so is it inside of a heated chamber or something? That sounds like one of those. Because I don't give any, like, a single fuck about thermal expansion. The only thermal expansion I experience is when the print is, you know, pops off the bed. Wow, there's going to be a lot of supporting material, isn't there? I don't have good bridging. My bridging is terrible because of the temperature of PETG. Oops. Because of the temperature of PETG, my shift? No, oh, that's right, just click. Because of the high temperature in PETG, my bridging is abysmal. Plus, that's on multiple layers, so it's going to be kind of ass. So we need the support material, and it generates it from everywhere. Now, I hear that this version has Hold on. New support stuff. Snug. What is that? Grid and snug. Pattern. Maybe not. Maybe it's the newer branch that has it. Huh. I tried for a full day to update my CR6 SE's to Clipper. Let's just say I'm back to Marlin. Ah, I love Clipper. Just because it cuts out all the stuff that your printer isn't, and you don't have to go looking in 5 different settings files. Marlin's fine, but it's, you know, Clipper having all of the settings just in one big file is wonderful. Not figure out how to get it onto the board. Oh, see, I don't. Yeah, I've got a custom board on this thing. Auto generate support, overhang threshold, force support. I don't think this has regular grid, create a more stable support, while snug support towers will save material and reduce objects. Snug might be what? Let's check. Snug might be the tree support. I don't know. Oh, I see. Okay. That's probably what we should have set it to. That would have saved us 2 minutes, 3 minutes. Oh well. That shouldn't be that big of a deal. Use linear bearings will make a full steel printer? That's going to be tough to do. That seems a little crazy. You're going to have to deal with multiple materials on something like that. Like, I don't think I can find like pulley bearings, and the brackets you can make out of steel, although it's painted steel. Bolts are going to be like stainless. I don't know how you would do an all steel printer. Use a spring steel band instead of a belt. That's be ridiculous. Ah, it's a shame I didn't do snug from the beginning, because now we're like halfway through the print. How far are we in this endeavor? Yeah, 55%. I got it right. I got it right. So I got 11 minutes to go. Oops. Yeah, before we make the follow-up to this one. A little bit easier to print. And with snug supports, it'll only support inside of this. I can punch it out of there. I got a rechargeable motion-activated light that's giving us the slightly better camera color and lighting. And oh, what is this? Severe thunderstorm warning. Whoa. Maybe we'll get a thunderstorm. What's it look like outside? I'm going to peek outside and I see the sun. What a severe thunderstorm. I love modern weather prediction. It's a good thing everything's turning to shit. I love it. How's this looking from above? Pretty good. Looks like the inside of a 3D print. I got those wobbly things going on in there. It is blue skies and sun. Like, I can't stress enough how little like a thunderstorm it looks outside. Although I do hear like booms in the distance, but I don't know. Maybe it'll suddenly be overhead. You can see the windows darken. I'm able to use the whole palette of sheet metal manufacturing machines. Ah, I see. That's pretty good. Oh, and then the breeze closed the door. Yeah, it's like, it says thunderstorm, but it's like bright and sunny outside. Unless we're going to get like a random thunderstorm dropped on us. And my ears are feeling difference in pressure. So there might be something going on nearby. I'm actually going to open up marysky.net to see the map. You guys are not allowed to see because it's doxing. It's like a direct dox of my location. Control and scroll. What's going on here? We've got nothing on Mary Sky, but Mary Sky has not been very good at predicting stuff. Oh, okay, everything is out west. Oh, wait a minute. East. East, there's a huge thunderstorm. Wait, but what direction is that thing going in? Oh, it's moving north. So it like totally missed us. We've got these little patches that are coming this way. Little patches of weather that are coming towards us. Here, we're zoomed out this far. You guys, I think, might not be able to. This apparently constitutes severe thunderstorm warning. It's not quite. It doesn't quite. It's not quite doing it. All right, close that before I dox myself. I had to double check what you said on your VOD. Your super slicer is still out of date. It doesn't have the tree supports. Yeah, I went with a release. I guess the other, the unreleased version. The lady work asking if we turned off everything in the data center when we had a power storm. So glad the intern came to the rescue with a straight out question asking, how do you work on a data center and not know we can't have downtime? Oh, should I be going with? No, the GitHub, right? And then if I go to the releases, where is that? Down here. I mean, should I be getting this one? Because this is still pre-release. This one's still pre-release. I went down until I found a release version, which I guess doesn't have the towers. Oh, that's a neat one. Max slope for overhangs. Batch of little fixes. Yeah, this is the latest. And this is what I got. But I guess if I went up to the latest RAF edition, no. All the way up here. 2.7. So this one. What it do? What it do? Win that one. Oh, Mac OS ARM. Sorry, I was like ARM. I want ARMs. Those are those ARMs. The tree supports. All right, so I'll do that in a bit. I have to do that right now. So down, close, no, discard, delete. It's dead. And then where's my downloads? Downloads. Go to this one. Downloads 2.7. Extract. Just use the latest. Okay. Delete. That's no skin off my back unless something goes really wrong with the 3D printer. That would be a hell of a thing. And then I hope that the cameras would be rolling because it would be an absolutely monumental VOD. Look at this. Father somehow got all the skin off of his back by falling into his 3D printer. It's incredible. Share this clip with everyone. 1 million billion views. I get the key to the city. If only my back skin were here to enjoy this with me. Yeah, Super Slicer. Fadanon used this for a little while, and it was kind of like the latest and greatest, and it worked pretty nicely for me. So I continue to use it in spite of everybody saying you need to go to Mainsail, you need to go to this new slicer, because everybody seems to move from this stuff. Like, I don't know, they don't have any agency or something. Exactly. Yeah, you got to go to Orca and you hunt that with a Mainsail, Moby Dick, the white whale, and then you got to go over to Lemix in order to go with function print, and you load that into your Flumbo drive. I can't keep up. I don't give a shit. I've already yelled at the 3D printer people a couple times about not giving a crap about what I'm using. Yeah, Super Slicer went through this long time where it wasn't getting updates. It's getting updates now, though. Just go back to Simplify 3D. I have a copy of that. Wexo bought it for me. I'm still on Prusa Slicer. This is a branch of Prusa Slicer, is what Super Slicer is. I can't keep up. Also realizing there's so many settings I never use and seems to confuse itself when changing settings. Well, the one setting that I had to do had to do with its generation of object stuff, labeling objects, because that caused a ton of errors. Yeah, let's see here. So supports everywhere. Support material. No, support just general. Huh. Organic. And then let's bring our print in here. See how you handle this. Whoa! Amazing! Wait, why are those coming in from there? That's just going to straight up attach. Oh no, it's got this huge amount of separation. Whoa! Whoa! Weird. Ugh. 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 I'll have to try it out sometime. That looks neat. 20 minutes. Finished at 16:44:18. Oh, it gives you a little time that it'll be finished. So you can go have a wank and a coffee and be just in time. These are gross. They're like tentacles. It's like bleh. It's like this alien's reaching out, touching my print. We went through all the letter error stuff on your synth front panel, and it was Super Slicer settings. Oh, so getting those letters smaller could have been solved in Super Slicer. I just run my printer using hand-coded G-code commands. That's right. I get out my little slot viewer and I pass it over the object and note down the positions of everything using MS Paint. How are we doing on this? Almost there. This is a cursed object for anybody who's tuning in a little later on in the stream. It's a foot from a Christmas tree stand, and we're missing one of them. So I am working on the 3D model to print out new ones, and they will be done in black filament so that they're not that visible, because the old ones are just rigid plastic. They're really not all that footy. It seems like they meant for this to be a rubber foot, and then they decided to make it cheap plastic. I don't have rubbery filaments, nor do I have a heated chamber. I have this exposed, dusty Creality CR10S, and I have PETG spools that are sitting underneath an open window. But all that being said, things print pretty reliably. It would behoove me probably at this point to throw some of these filaments into the dryer just to make sure that I don't get all these weird inconsistencies. And then it would be a good idea for me to update all the software on the printer at this point, because I think there's probably a couple new features and a couple new things that I could tune out and get the printer to work just a little bit better. We're at the point where I should probably just buy a new printer. Usually when we get to that point, I just rebuild the whole printer. But It's at the, like, 3D print technology is kind of at a it's, I want to say some other word than point, and I can't come up with it while I'm talking to you guys. I just can't find a new word than point. The state of 3D printer technology is that I could just, like, buy a Bamboo and it would just work, or I could buy a Creality, like one of the newer ones. Yeah, the K2 Plus. Can't wait to have an enclosure in multicolor. Multicolor would be a very interesting thing. I don't do much FDM anymore. The Goop printer that I have has been sitting idle, and I'm afraid of the state of it because I accidentally left the Goop in the bottom. I got some really good prints out of the thing, but I haven't had much use for it after that. Printing this in that plastic would probably be an interesting thing, because then it wouldn't have these sort of stepwise ridges that the slicer, the FDM slicer, brings to the table. Also, lowering my layer height might be a good idea at some point. Now we gotta let it cool. Let it cool. But I thought it cool. Here. So we're just waiting for these two guys to get low enough that they sort of are beginning to cross one another, and then I will take Windex to the part, and that'll shrink the part, and it'll shrink the glass, and then they'll hopefully separate a little bit more easily. Also, some of the detergents that are in Windex will get in between the print and the glass. Yeah, I don't really have the money for a K2 Plus. One of the other tools that I wish would be bequeathed to me for you know, oh, look at this streamer guy, let's just give him something expensive. I wish that happened to me more, because that laser welder that's coming out looks really amazing. It is a laser welder that also you can attach the welder to an XY table. So I could do all the car repair that I need to do would be amazing with that, because I could just take a piece of cardboard and figure out what the what do you call it? What the piece of metal should look like that I want to weld in, and then scan it on a flatbed, put that into a vector program, cut it out of metal, and then weld it to the car with the power of lasers. That'd be amazing. That would be the dream, is if I had enough viewers to do a weird project like that. Use the plasma cutter to eviscerate a Tesla and get the motors out of it, as well as the batteries, and then put that into something weird using the welder. It's like, look, it's all one tool. There'd be so many problems with that project. I would hate it after a little bit. Dreaming about it is one thing. When it actually putting rubber to the road is where all of the issues arise. $350mm cube print volume? Where are you going to put it? Well, okay, cars don't have straight sheets, but you can get, especially with the repairs that I have to do to my car, you can get by with a straight sheet. It doesn't need to be totally straight. You can bend the edges of it a little bit, but this is the, on the unibody, it's the part that runs along the skirt. And so if you just get that edge properly, you can put a flat plate in there, and then the jack pad goes onto that. It doesn't need to be perfectly, you know, matching the curve, because it's basically under the car. But, you know, there's any number of ways to modify sheet metal in order to get it to kind of fit to the specific shape you want it to be on. Punches and whatever else. All right, we're getting close to the overlap point. There's the overlap point of the two. So I am now going to force the issue, because we're streaming. If I wasn't streaming, I wouldn't force the issue. I would wait. Patience is key, but, you know, so's content. Stuff's got to happen. Scoosh. Another cockamamie 3D printer idea that I've wanted to do is the water-cooled 3D printer. I think that would probably warp most parts that you'd print in it. But if you could water cool this bed, ow, it's hot, you could have like a diverter valve. So you would be water cooling your hot end, and then you would, just because you can, run the water through all of the stepper motors to cool those, even though they don't really get that hot. Stepper motor drivers would be water cooled. All of that's one circuit, but then you would have the ability to switch the pump over to a second circuit that would go through the bed. And so when your print's done, you would open that circuit up. Your fan would be basically just ejecting really hot air as the bed cooled unnaturally quickly. There we go. And then your print would probably pop off a little faster. I think that would be awesome. Maybe one day. Maybe one day. Maybe if Bamboo Labs gifts me a printer. Oh, Bamboo Labs, thank you so much for the printer. Or a Creality or something else that I can hack. Then you get a hidden leak somewhere. You guys, listen, my water-cooled computer has been running perfectly fine for, has it been a year? Yeah, Bamboo's gotten a little shady with the phone home stuff. The walled garden stuff that they're doing. So maybe not Bamboo, but if I were to buy the printer, if I were sent a Bamboo printer, you guys would hear me talk so positively about them. You have no idea. I would be so positive all the time. Oh my goodness, this is the best printer ever. It's amazing. I love that they have all of my personal data. I love it. I love giving data. I love giving my data to companies. I love it. But yeah, just one of those nice printers. If you modify it to do that, that would be pretty cool. I don't want to break the thing. I think it's strong enough as is. With PETG, separating the supports is always very annoying. Because it's so sticky. And I found that the flathead screwdriver is one of the better tools for it. But I am much, much softer than a flathead screwdriver, I've found. And so I got to be real careful not to destroy myself while releasing these supports. There you go, that's one end. Like the knife is not strong enough for this. I see folks that have classic HDD laser 3D printer complains about dust particles in their print after they use the laser function a few times. That's interesting. Never thought about that. Yeah, laser stuff is actually a lot less clean than people think it is. Having those as separate machines, that's interesting. It's a good idea. What I love about that the laser welder is that you can use it as laser rust removal as well. So it's a plasma cutter, it's a rust remover, and it is a welder all in one. And there's probably other parts where it does not excel, I'm sure. Problem is it's $6,000. It's a little bit rich for my blood. I didn't quite get that on my tax return this year, you know? I got negative $300. So, bother's hurting a little bit today. My investments went really well last year. Obviously, they are not going to go well this year, so I don't think I'm in any danger, but I almost priced myself out of the healthcare program because I didn't know that the people running my investments were doing fucking gangbusters. They did really, really well. Really well. And I didn't have burn the subs running, luckily. If I had burned the subs running, I probably wouldn't have health insurance. That's a tough thing. Yeah, milling is obviously more dirty, but... Did you get one of the milling and 3D... Wait, there's a mill and 3D printing combo? You'd have to clean the hell out of both of those in order to get it running. Huh. Yeah, maybe some machines are best left to separate setups. Because, yeah, the types of stuff, types of mess that the two create are not compatible with one another. Imagine getting, like, metal chips in all of your prints. All right, let's see. Let's see what we got here. So, slight... Oh, wait, we're not done yet. I don't really need to clean this up, but I can see it, so... This is where I stab myself in the hand with a screwdriver. And then somehow, between me and Uo's lab, I'm the one that gets the serious injury. Okay, so now let's compare the two. Wood milling is the best that it can do? Oh, so it can't quite. I'm sure it could engrave metal, right? Just not at its super duper speed. That's the thing that people, they're like, this thing can't do that. And it's like, well, it can. You just got to slow down. Nobody likes slowing down with these fucking machines. It's ridiculous. They, like, all these YouTubers that do like milling and stuff, they run the machine at the ragged edge of what you can accomplish. And they're like, all right, I'm gonna do this cut, and then the milling machine is like, ah, and then your end mill blows the fuck up. Like, slow it down. You don't have to run at the ragged edge if it's a hobby project. If you're not making money by the minute on it, there's no reason that you have to be at the ragged edge of what the settings can handle. What is this? Modular 3-in-1 printer. I've seen these before. I'm not going to look at that right now because we're going to compare our two objects here. So that is a little bit more accurate, although it's still big. Hard to compare them because these are all angled at weird angles. Looks a little better. So let's see if it fits. I mean, ignore that. And then I've got the channel at the back that I can use. Squish it in a little bit. It's a flexible bed slinger. It's painful to watch this floppy thing milling. So rigid this up a little bit. This is our test foot. This, we'll just see here. I don't think it's going to flex very much, but it might be just enough for it to fit properly. Oh, wow, that fell right in. Actually, that's the problem. So can I get it out of here? That fits like perfect. That's so much. So if I can move the metal in a little bit to pinch on this, because this has been flexed out of position. This appears to be pretty good. It's just moving around a lot. So here, let's get this out of here. Come on. Out. Outie. Ugh. Jeez. Pinch this in. Yeah. If I could do flexible filaments, then this would be a perfect application for that. Oh, yeah. Oh, yeah, look at that. Look at that. Oh, yeah. Oh, that's a good fit there. Even the little bit of support material that I accidentally left in is displacing this a little bit. The controller is connected with a standard USB-C connector without additional locking. Wait, without locking, does it just fall out? So if I place the legs on the rest of this thing, I'll probably print 4 of the 3D printed ones and just, we'll put the 3 near each other. Move the calipers out of the way. You can get all 4 legs on the bench without completing a circuit on a bunch of capacitors. No, no, I'm finding out. Nah. God, there's so much crap on this desk, it's all getting in the way. It does 3 jobs badly instead of doing 1 really well. Hold on. Where is that? I don't have it. I was gonna write success. Hold on. I can't operate my own computer. Text. You have a weird font. Yeah. Yeah, we did it. We did it. All of our stupid measurements worked properly for once. It is a chair, a leg for a Christmas tree stand. Amazing. So much talent. So awesome. We did it. Thanks to Fusion, to the power of, to the ability and power of Fusion360. Yeah. We succeeded. We did it. Yeah. That was a lot of work to get something so stupid done. Hold on one sec. Let's just take this over here. Let's do. Mm-hmm. Mm-hmm. And replacement foot. Feet. Those feet. I don't think I don't think we'll be able to find them for sale. That's kind of a reach. Yeah. This is this base is special to this tree because it's a plastic tree. So I think the whole thing is sold as one big thing. I don't know if you could find a replacement specifically. Although that's a rotating one. That's even better. Nah, we probably wouldn't be able to find it. That's not the right. There it is. Success! We made a Christmas tree leg. Ta-da! Laser cutter and 3D printer with a good air ventilation, possibly, but 3D printing and milling is not good because this type of machine is using opposite kinematic philosophies. Yeah, then that's... I haven't done an XY where you have a lot of force on that, on the thing you're moving around. I haven't done one of those yet. The laser engraver for Burn the Subs is, again, one of those other ones with that philosophy of, well, nothing's going to resist, so you set all the settings differently. I don't know. It's a weird one. The milling process does not require a clean room, and it creates a lot of mess. I can see that as being the primary difference between the two. Anyway, Christmas tree foot, success. It looks a little crappy. It looks a little melty on the front. I think I might dry the filament. I think that might actually solve that problem. These have been sitting under a moist window for quite a long time. So, yeah, it's what it's. It's what it's. But the light gray is great now. We have a working model. I'm going to switch over to black filament and print 4 of them. And then this will be just as locked down as it ever was. I have a feeling these were supposed to be a little bit more rubbery than they are. So even that texture on the bottom of them is kind of misplaced. But that's something for me to do off air because printing 4 objects is going to just be really annoying. So anyway, success. We did it. With the power of friendship and Fusion360 and anime on our side, we were able to create a working model of working and adjustable model of this 3D print. We were able to get it out very quickly because the workflow from Fusion360 to the 3D printer I have worked out. I could make that a little bit better. I could possibly even make it start the print directly from Fusion. But in the future, I'm going to be using Super Slicer, the one with organic supports, to make these creepy looking alien fingers that go up and support my print. And we'll see how those go in black filament. I will possibly post an update. Yeah, we actually did a 1-stream project, and I'll catch you guys up on that next stream. That makes it a little bit more than a one. We'll count this as a 1-stream project because it's done, right? It's successful. You know, the only spaghetti regretti that I have is that our height is a little bit too high in order to see the effects of something like this chamfer. It's supposed to match the sheet metal that's bent, and it probably won't. Well, no, we know it doesn't because it happens in 3 layers that are just kind of like, you know, I don't know. What is the thing they say about the shrubbery? It's a sort of a layered effect. But yeah, anyway, good stuff. So I'm glad that I did that so I can get that off my list and I can get this stupid Christmas tree stand out of the shop and move on to other stuff. So Thursday, it's still this week. Thursday, what we're going to do is we are going to make this circuit here. And this circuit is a 100 volt emote thrower. We put 100 emotes through this volt on this loop right here, and that is going to energize this coil and emote my throw vertically into my face. I've done a little bit of some very rudimentary circuit work. If we go through an 800 ohm resistor, we run this power supply at 125 milliamps. So that is still screaming hot, considering that it's going to be about 80 to 90 milliamps at the voltage we're asking from it, and that will charge it in 4 seconds. We did a test earlier in the stream to see what 4 seconds was like. Putting an emote in chat, 4 seconds, ideal light turns on. It was excruciating. There's no way that I'm going to allow that to be 4 seconds. So what we do is we put a high voltage transistor in parallel to the current limiting resistor. So this transistor turns on, that'll start the charge through the current limiting resistor. Then this one turns it on, and we get that quick charge that we got before. And then the question is, will it blow up both of these transistors when I do that? We may have to keep it on this one, in which case I got to find a better transistor. Would it be possible to print without supports if it's rotated 90 degrees? You have to understand how terribly shitty my printer is. Because I print in PETG, it can't handle anything like this, like no overhangs. And we put this big cut in here so that it was, at least theoretically, able to be flexed. You know, this part down here would flex and allow me to remove it from the sheet metal that it clicks into. So I don't think there's a geometry where this thing would go up without supports. If I turn it 90 degrees, it would probably be able to handle that overhang. But then this is done in multiple steps because it's at a weird angle, because it's parallel to this piece. There's a lot of weird design going into this that they didn't have to worry about. We have to worry about it because we're on a 3D printer. They didn't have to worry because they just injection mold this. Throw it over to the other engineers. They'll figure out where the injection points are and all that stuff. And then they decided, you know what? Making this rubbery material is not worth it. So let's just make it out of hard plastic. Nobody will notice the difference. But the difference is that it slides all over the place. So I'll be able to print this on a PETG, and it'll feel exactly the same as it does right now. Yeah, well, let's see what the slicer thinks about it. So, burp, burp, burp. I guess that works. Well, at least that's a little more uniform. My weird alien fingers. You could almost get away with no support on that. Because then it'll just try to bridge that, and that'll sag a little bit. I can cut off the excess. It'll be just a little droopy droop. But I kind of want to try the weird supports. But yeah, I'll try that with black filament. I'm going to switch the filament over, and I'll try to print this weird alien device. The tree supports really do make it look alien. I kind of love them. All right, I'm done. Here's face cam, and then I'm going to get this out of the way so I'm a little bit more centered. I gotta find something better than this bin to go here. I like to have this bin available, but it's not a good look. It kind of looks bad. I just go with the wood of the desk like that. That's a little better. I'll just shove that thing back there. I'm not muted. Not muted. Sorry. You gotta look at your settings or hit reload or something like that. Yeah, I got plenty of volume. I'll be back on Thursday. Here is, wait a minute, end card. Ba-bam! You got 1 day, 19 hours, 43 minutes, and 20 seconds, and I'm coming to find you. I can assure you that I am talking into the microphone right now. You guys, multiple people are saying there's no sound. I don't believe you. Because I'm talking right here. You can see it. There it is. That's me talking. Yeah, you guys can hear me. Okay, good. It's just when one person comes in. All right. Just quieter than other streams. How am I quieter than other? I don't understand. I am talking full volume into OBS. Like this, I am broadcasting out as loud as I can possibly get. I don't understand how other people have more volume than me. Can't hear them on the phone. I don't understand because I'm outputting at max. I do not get that. You guys are in cahoots with each other or something. What other audio settings do I have? Settings, let's see. Audio. Speakers. Delays. I don't know who you're talking to because if I go any louder than this, I clip. Yeah, there's nothing else I can do with my audio that makes it any louder. This is on you guys. Unless I sneak up that volume thing a little bit and totally ruin it, but I am in the yellow. I'm talking and I'm in the yellow, and here you can see it. If I drag this thing over here, you can see that my speech is in the yellow, which is the danger zone where you will begin to clip if you get into the red. So you guys need to like figure this out. And I think maybe you guys are in cahoots with one another. Wait until you get a Windows notification. What, with your sound up all the way? You guys are just, yeah, you guys are two people who are friends with each other and you're conspiring in order to make the streamer feel that. I'm ending the stream right now, so I don't really care, but the difference between my stream and other streams, I don't know what to tell you guys. You think I should be at the edge of the yellow-red transition, but when I do that, here, there we go. There's my new volume. I'm all the way up here, and people are going to start talking about how there's clipping noises on my audio. Sound is 55% for other streamers or YouTube. I don't need it that high. Clipping at the moment. I don't know what to tell you guys. I've put a lot of work into my audio here. So that if I talk loud, it doesn't blow up your speakers. All right, I'll leave it here. I'll leave it here. I don't, just two people come in and say your audio sucks, you're terrible. Everything's good, good, good. Yeah, and then I'll unplug this and plug it in again. Here, check it out. Again, put this back on, and depending on which driver my thing chooses, it might get louder or softer. Clipping on the Focusrite. Check, 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 check. I don't see it getting yellow on the Focusrite, so maybe that got adjusted. Hold on. Checking volumes. I'm talking loud. And if I talk loud and this goes up, it's going to start sounding awful for you guys. There we go. Okay, so that needed to be tweaked a little bit. So now I'm going to lower this one. Check 1, 2, 3. Yeah, now we're in the red over here. So I'm going to lower that just a little bit. -10 because I am cooking it over there. 9 maybe? Yeah, that's so loud noise. Sometimes it chooses a different driver because of or a different, like, I don't know what it is. Just some of the audio stuff kind of is in flux. Possibly because it's warmed up now. Check 1, 2. Okay, so that's going red. So I should be down a little bit from that. Headphone versus non-headphone. It should be pretty universal that my volume is okay. But yeah, this is, I'm not going into the red because it makes nasty crackling noises for you guys. I done gigs recording with a professional audio engineer while I was at music school, which is where I got the 3 dB rule. I don't know if the 3 dB is really a so much of a rule. Maybe it should be at negative 3 dB. Negative 5 dB on the meter that I'm given here is in the red. So if I go up to negative 5, because we're at negative 10 dB right now. I don't know. Look, I don't like that it's clipping like that, you see? This one puts 0 dB at the very top. It's not a very good scale. OBS is not exactly professional audio equipment. You're still not hearing clipping? Somebody's going to talk about clipping. It's always different because it's like you have to do like a full mix down for these people. Clipping should be when you hit 0 dB. I'm not going to take this advice because I've set everything up. Like, I don't get you guys. You guys will run into a stream. People have said my stream is great and perfect. Jeez. You guys are tough here. I don't know. I gotta see somebody else's OBS set up and see what they're setting it to, because my understanding is that red is clipping territory. I don't want to be all the way up in the red. All right, well, this was very distracting. I'll talk to you guys later. Bye.